Welcome back to Hoffman Tactical. In today's video, and before we get started, let me turn off this creepy music, and then we will continue with our intro. The music is creepy, I will say. Okay, so continuing with this video, welcome back to Hoffman Tactical. In today's video, we are going to be doing another live stream where we're going to be discussing CAD design and some of the different techniques we use to design frames and receivers. And I have on a very special guest today, and that is Chairmanwon, and he is known for his Glock frames, which are have a heavy focus on ergonomics. So he's done a lot of CAD modeling. I think by the name Chairmanwon, you can also guess that he's also designed some furniture. So that's kind of his background. So he's done a lot of CAD modeling, and obviously I do a lot of CAD modeling. So we should have a really interesting stream. The goal of today's stream is going to be discussing surfacing and doing more complex curved surfaces and why we do that, and kind of trying to demystify surfacing a little bit and talking about some of the different techniques to maybe help you guys step away from some of the more basic extrusion solid modeling techniques and get into a bit more complex surfacing and doing more organic curves and such on your parts. So with that said, I think I'll bring Chairman on, and I think actually he's not quite here yet, but he will be soon. Let's see. All right, just a second there.
And... whoa! Hey, sorry, it was just a chair there. You know. I was so inspired by that Herman Miller CEO lady's little speech about people working harder and not working for money that I decided to buy one myself. Don't worry about it. You don't get the reference, but
I don't know if our viewers do either.
Oh, it was big on the internet this week. But hey, how's it going, man? It's been a while.
Yeah, it's been a while. I'm super glad to have you on again. This should be a really interesting stream. Back to more, probably very dry for most people, but back to more CAD design discussions. So that's what we're going to be talking about today. And I hope you're ready.
Topic today is surfacing, which is a word that gets thrown around quite a bit. People talk about surfacing. They say, "Oh, this is a surfaced model." It's kind of like a magic term to inject quality into how people talk about their CAD models. But
yep.
I feel like not too many people really kind of understand what we're talking about there, and why it makes such a big difference from kind of the type of CAD that most people are used to. Those are some surfaces.
Lots of surfaces. Actually, 100%. This guy here is actually 100% surface, so not a single solid body in it until, of course, we complete it.
But wait, that's crazy. That program is called SolidWorks. How are you working without solids? That doesn't make any sense. I'm super confused.
It's very disingenuous, and I actually haven't really thought about that too much until you mentioned it. But yeah, SolidWorks was a really bad name since we actually are not working with any solids at this point. I guess solids is an option and the end result will be a solid, but as of now, it's strictly surfaces. So there's no actual solid here. It's just three-dimensional surfaces, but they have no thickness. So there's no actual body here.
So I guess we should start with what is a surface. So a surface in CAD is an object without any thickness. So a surface is made by three or more edges that are bounded in such a way, and that bounding box, that two-dimensional plane that is the center of that polygon, is what we refer to as a surface. Now, it's not just something where you draw a square or draw up, two curves and connect them, and that's all you can do. In surfacing, you can do a lot of stuff by controlling exactly how that surface progresses through that, shape. So you can see, what Hoffman has here with the grip. That's not just a straight connection between. So hold on one of those surfaces so people can see the bounding.
Yeah, let me.
Yeah, there you go. If you just mouse over it, people can see it. So you can see how there's connections, the edges. But the surface is a lot more than just connecting all those edges.
Exactly. So basically what it does is it allows us it allows us to do a lot more complex geometry without all of the headaches and problems you get trying to do it with more traditional solid modeling techniques.
So, what Tim is saying here is that in solid modeling, you have to have a valid solid. So it's in the name, SolidWorks, my program, Solid Edge. The only type of geometry that these programs recognize as valid is a solid model. So in old school, kind of like CAD, if you're a Rhino person, you might recognize the term watertight. So a watertight model, a solid model, that's the only type of stuff that these programs recognize. Surfacing lets us break out of just working in the constraints of, hey, what's a valid solid? And then we can apply what we get out of surfacing back onto those solids. And so, Hoffman, I think you and I probably work in very different ways. So it looks like you're basically building something out of surfaces and then basically thickening it.
Well, so I'm not thickening. Actually, what I'm going to do here is I build the entire part and then I simply stitch. I build.
Yeah, you stitch it together. You stitch the surfaces together.
I build the watertight model completely. So right now it's obviously not tight at all. But
so that's a very Rhino-like kind of way to go about it.
This is not how I have usually done things. This particular model is the first time I've done this, just because it's making it easier.
And that makes sense. So the general way I go about it actually is I start with primitives and then use surfaces to basically modify off those. And, that might be a face replace. That might be a Boolean operation, thickening a surface and then using a Boolean. So
that is very, so I do not use Boolean operations at all, actually.
They can be very powerful if you use them correctly.
Okay, yeah, I definitely need to lean into that some, and for whatever reason, SolidWorks just froze up on me for no reason. But are you still there?
I'm still
here. Okay, you're still there. Okay, yeah. Yeah, that's weird. For absolutely no reason, I didn't even click on anything. I don't know if anyone can see it on the stream.
No, your model is still on the screen. It's just not moving or anything.
Yeah, it's frozen up for whatever strange reason. I'm not sure why. I think I just...
there we go. It's back.
Oh, now we're back. Yeah, that was kind of weird. Yeah, welcome to SolidWorks, everyone. Yeah, so in this particular case, I could bring up some previous examples of what I've done. But in this particular case, because I'm the problem with using solid bodies and mixing surfacing and solid bodies was I ended up cutting the solid apart into surfaces anyway. And then I would restitch it back together. And if I went back and wanted to change something, I could run into reference problems. So I would go change the solid. And then when I restitched it, I would run into reference problems later on.
So that's where Boolean operations become really powerful. So
you don't have to worry about them being directly linked to the other geometry.
Exactly. So a Boolean, so basically, let's say you... Here, switch. Give me priority on the make me the big box.
Let me go. I think I can go. Let's see. How do which button do I hit here?
There should be a way. There should be a way to full screen me.
Yeah, there is. I don't know why it's not. Let's go. There we go.
Alrighty, so. You can see here, this is one of kind of my V3 models. And if I show all of my surfaces, you can see a lot of these are what we traditionally recognize as surfaces. So
now, are those surfaces or those planes?
A plane can be a surface.
True, yes, but I mean, so in SolidWorks, there are reference planes, which are treated by the program like a surface, except they're not actually valid geometry.
Yeah, well, so SolidWorks and Solid Edge treat things exactly the same way because they're both based on the Parasolid modeling system.
Yeah.
Sometimes I'll use surfaces like planes just so I can control them from sketches in a more easy parametric way.
I now do the same thing. Yeah, exactly. Yeah.
So sometimes if I want a reference plane, I'll make a surface just because that surface can be defined just as an extruded plane. So it just sometimes makes my my parametrics a little bit easier. But you can see here I have quite a few surfaces, and Solid Edge calls these construction bodies. But I have quite a few surfaces that have some thickness to them. And those are basically self-contained solid bodies that are defined by surfaces. So like this thumb groove, and I use a lot of these.
This is interesting. I haven't seen this before. So you're using these to kind of cut away at the main part?
Yeah, hold on one sec.
We're having classic CAD problems here.
Yeah, you know, it works fine on and so I'm just hiding my my screen while I pull this back up so I don't dox myself with some directory name or something. Sorry, I'm just gonna open this not in the context of an assembly. And there we go.
All right.
And we're back.
All right, there we go. And I'll make you big. There we go.
All righty. So I'm going to show all of my surfaces. And that obviously takes a second because I use quite a few of them. And so, yeah, each one of these surfaces is actually a... So yeah, here's one. Here's a good one. So this is what's creating the front strap. And it's not like connected to the rest of the model in any way. So it's a surface controlled by sketches that's then extruded out into its own unique design body.
Is that a thickened surface?
Yeah, it's a thickened surface. Okay. And then that basically becomes its own watertight model that's separate from the main design body. So,
and then are you using that to cut away from the main body?
Exactly. But the really nice part about doing it this way is, so this becomes a construction body. So anything that's a surface or a, you know, actual solid, you can say, hey, this isn't part of my design. I'm just using this for constructing the actual design. So it doesn't actually, like, even though geometrically it's just as much a valid solid as any other part of your model or any other real model, any other real solid body. It just basically gets ignored when it comes to, you know, determining what's a solid or not, or what's a solid or not. So this is a thickened surface that's controlled by, you know, maybe 4 sketches. But if I want to change that front strap, it's not, all of those sketches and those surfaces aren't directly tied to the rest of the model. They're just tied to this one design body that's only interacting with the rest of the model through, you know, a Boolean subtract operation.
Now, wouldn't that cause integration though? Like trying to blend that smoothly into the rest of the model, wouldn't that make that more difficult?
Well, it's very early up in the design tree. So, you know, the first things that I'm defining on a model like this after the basic shape, you know, hey, it's a handgun frame, is I'm defining the front strap, I'm defining the back strap, and I'm defining the thumb groove, because those are the biggest, most complicated, you know, surfacing operations. So those go really high in the design tree, and those go on, you know, long before the trigger guard. So you can see I'm hovering over the trigger guard, and you can see it's showing all the surfaces that end up making up this trigger guard. But that's kind of one kind of self-contained thing that's outside of that. So you can have major parametric problems if you try to like define your front strap, back strap, major, you know, ergonomic features before you start putting on all of the, or sorry, after, you know, you start putting on all these add-ons like trigger guards and, you know, stuff like this. But if you order things correctly, basically from like largest, most significant features down, you know, yeah. I can still change up until the point that I put this groove on, you know, for the for defining the stippling. Up until the point that I put that groove on, I can, even with everything else built on top of it, I mean, thousands, I mean, more than 1,000 operations in. I mean, I'm on face replace number, just for face replaces, I'm on 761 by the end of this model.
That scares me. I don't know. I want to try to keep things in the dozens if possible.
Oh no.
Not when using those techniques. So why
No,
do you
no.
why did you back the tree up some and give people a more of a look at the raw model?
Yeah, for sure.
This is probably going over most people's heads who haven't worked with this yet. Yeah, that's an interesting way of doing it, using separate bodies and then cutting them, and then using face replace. Like I've used that a couple times, but I tried.
I use face replace. Like I fucking.
I know.
I'm like a crackhead addicted to face replace. I use face replace so fucking much. So this is actually just a this is a whatever model. So let me this isn't like a live model. So let me back it up quite a bit. And back it up irreversibly so we can do some surfacing on top of it.
Irreversibly? What's that mean?
Well, I'm literally just deleting a shit ton of features because this is just a copy saved out. It's not like
I see.
It's not actually on my NAS. This is so here we go. So yeah, I was about right. So that pretty much brought this back to, you know, pretty much just its primitives.
Oh, it's rendering those surfaces. I guess you probably have it set to render them more coarsely to save on processing.
Yeah, I know what it's going to look like. So here, I'm going to hide these. So here's my 3 big surfaces. So let me hide everything except the surface that makes the backstrap. And I'll show you that even when the model's at this stage of complexity, we can do big ergonomic changes just with the toggle construction. Okay, here we go. There's that. Sorry, I really want to make it so that we're seeing all the right stuff. Super important backstrap. Oh, here we go. I actually named it. Super important backstrap hole offset. Yeah, we'll hide that.
Okay, that's nice.
So, guys, in case this is being lost on the folks at home, Tim is a lot more organized than I am.
Well, so I'm doing things that are a lot more. I would use the word simpler. I think would be appropriate. You have a lot more features on your Glock frames that I'm using on lowers or the Orc or anything else. You have a lot of small features and profiles that you have to deal with.
So here is the all-important backstrap surface that is defining basically like the key ergonomic feature of a gun. So your front strap is important. Your most important ergonomic feature in a handgun by far is the backstrap. Everything from the bottom of the handle, you know, the bottom of the grip here up to the end of your beaver tail. That's by far like the foundational ergonomic feature of your gun. I mean, and it makes perfect sense, you know, when you think about it for just a second. Here, I'm gonna just switch over to my camera focus. So not a gun, YouTube, just a piece of plastic.
Just a piece of plastic, biodegradable plastic at that.
So you grip something, the web of your hand between your thumb and your forefinger is the most sensitive part of your hand. Like try getting a paper cut, you know, between your fingers.
Yeah.
And you're putting that most sensitive part. That's where the most sensitive part of your hand interacts. And then when you grip something, that's the foundation of your grip. Everything else is built on top of that. So you focus on the backstrap. That's your foundational ergonomic element.
Well, welcome back to Hoffman Tactical, guys. In today's video, we're going to be doing a 2A 3D development stream on ergonomics. Ergonomics 101.
So I mean, hey, that's
exactly.
what surfacing is for. It's for going from something that's really blocky extrusions to, you know, something that's actually shaped like a human hand.
Yeah. So why don't you show people how that surface is made? So
exactly. So let me show all my sketches. There we go. I have a lot of sketches as well.
Screen your share.
I'm
sorry. Your
screen
screen again. Yeah. Bring it back up. There we go. Perfect.
So
okay. So just to kind of get people up to speed here, what you're looking at, this particular surface we're discussing, you're thickening it using Boolean operations to actually apply it to the model. But all of that kind of is secondary to the main instruction here. this surface is the profile that you want the final model to be in that area, at least
So
at this stage in the design.
So I'm going to highlight the sketches that really kind of control this. So these are the sketches that are actually controlling this surface. So this most foundational element of the gun is really being controlled just by these three surfaces. Or sorry, by these there's
five or six, I would think.
Nope.
Is it only three?
It's only three, so it's 1, 2, 3, and then one of them is a mirror. So yes, it's 4, but one of them
is just mirrored.
Yeah. And I'm letting the tail wag the dog at the bottom. So I'm just letting what I'm controlling on these.
The tail is just floating. It's just an extension of the top surface.
Yeah. So this is where like the guide curve is actually important, is this one right at, the webbing of your hand. So I'm letting everything else flow from that. I'm just not even why wouldn't I let the top and the bottom fall naturally from from what profile is most comfortable for the webbing of your hand?
Yeah, unless in this application, that's perfect. So how are you keeping that surface tangent with the rest of the grip?
I
think that's
these sketches on the side are coplanar with the rest of the grip. So the edge of the surface is going to fall on the same plane.
Yep.
And then in the actual surfacing operation,
open that up. Yeah, you can do a lot of define a lot of stuff.
So this is, you know what? Here, let me go.
This is the best view you've had so far.
Let me go all the way back to the replace face or the subtract operation there. So the subtract, replace face, front strap. I'm gonna take this model all the way back to just what we're talking about. Okay.
Much cleaner. Our frame is now looking much more rudimentary.
So I'm going to hide this surface real quick. And I'm going to roll back to the subtract operation. So I'm going to go to toggle to construction. So before this surfacing operation, this is the base of V3. So like you guys have seen V3 and how flippin', ergonomic it is.
You start off with a solid extrusion.
This is the ergonomic this is the foundation of it. It's just a solid extrusion.
Very much in the way almost that it would be done in like a mesh type program. Obviously it's parametric. You're not using a little brush to push and pull, but you're starting off with like a block and then you're taking that block and cutting it until where you want it.
Yeah. So in this first operation, you can basically just like draw a Glock and you can set up like your most important elements. Like I want the grip angle to roughly be this. I want, rails here. I want, a taper, I want a slight angle here that's going to like bring this up to here. And, at this point I put in some of like my significant interior voids, like the magwell and the front rail block, just so I don't cut so deep that I, infringe on those. And though they shall not be infringed upon. So we have these sketches, and these sketches are controlling this surface. The most important ergonomic feature I can control right here just by grabbing this point. So this will control the backstrap. Even when the whole model is built on top of it, this will still do that subtract operation. So I just modified the backstrap a bit.
Do you just drag and drop those like sketches where you want them, or do you define them with dimensions to kind of lock them in and then change them later?
I don't really use dimensions for ergonomic features.
Okay.
Why would you? Dimensions have no relationship to ergonomics.
Yeah. So I use them kind of more for. I like to dimension everything. Once I get it where I want it, I'll dimension it, and then I kind of like to use it as a reference. So when I want to change it later, I kind of know I can put it back, or I know how much I'm moving it, and then if I want to put it like halfway back, I can do that. So
I don't like dimensions for ergonomic features. It doesn't like fundamentally make any sense to me, right? So,
but it gives you a point of reference to work from when you're making changes.
But that's stupid. The only point of reference that matters is the actual point of reference. Like, because you're not like, no one's smart enough. Like the system of your hand is a shit ton of joints, a shit ton of nerves, a shit ton of ligaments.
Well, it's based on feel, but you print the model out, you feel it, you see you want to tweak something here, change the curve on the backstrap a little bit. I like to use the dimensions in there. That way I can go in there and I can move it by a little bit. I'll know how much I moved it. And next time I say that's not nearly enough, I can move it by twice that. I just feel it gives me a better idea of how I'm changing it in the model rather than just dragging it. And then I have to go back. I have to go back to my last version if I want to know how far I moved.
That's very contrary to the way that I like to work. I like to set my technical constraints. So I like to say, you know, here's my grip angle that I'm targeting. You know, we're going to target like a SIG P320 grip angle.
Mm-hmm.
I want to target, you know, obviously it has to be a Glock. I can't make shapes that are incompatible with its like fundamental Glockness.
That's right. Yeah, you have to. That's the very basic shape of your frame, though. That's not any minor. That's not any minor ergonomic part.
But the ergonomics aren't minor. Don't fucking say that.
Well, okay. minor.
But like, I'm serious. It's the only thing that differentiates what we do from what the rest of the gun industry does. Like, yes, there is the 3D printing element, but that's not an affordance. That's not intrinsic to the object. So if you're just talking about the design of the object, the only thing that makes us different is our ability to do things that traditional manufacturers can't. So ergonomics is a big
part of that. Yeah,
is a huge part of that.
Yeah, that's a huge part. There are some, exactly. There's other things as well we can do.
I mean, but you know, like, what I try to harp on with this stuff, and you know, I think it's a lot of what has made me, you know, like a popular designer in this space is so many people think of 3D printed guns as an end. Like it's the means is the end. Like the whole point of 3D printed guns is to 3D print guns. Them. And that's the only thing that matters, right? Like,
but that's not really true. There's actually more you can do with it.
Well, no, it's true, but there's nothing you can do as a designer to make 3D printed guns more 3D printy. Like, right? Like it's intrinsic to the space. So as a designer, like you're not going to make a 3D printed gun more 3D printable. Like, sure, yeah, like the FGC stuff like that, but like you're not going to make it more like
you're not going to make a Glock. You're not going to make a Glock more 3D printable. I mean,
I just mean like
within the scope of the project, it's not going to. You have to, if you want to do something that's better than another frame or an older previous frame that was out there, you have to actually do something better other than just printing.
And
ergonomics is where you're doing that.
Well, in product design school, we have like a fancy, academic word for it, and it's called an affordance. So like the price of an object isn't an affordance. The cost, like the regulatory stuff around an object, that's not an affordance. So the fact that 3D printed guns can be, unregulated and like people have better access to them, that's actually not that's not an intrinsic property of them. That's a property around them. And so people often don't disentangle the object from the all the other things around the object. How much does this object cost? How easy is it to get? How durable, how long it lasts? Like that, those aren't,
Well, some of those could be tangentially connected. Durability is
sure. That's a bad one. That is a property of an object, but like that's not. I meant that more in the sense of like, hey, did this person print it out of good PLA plus, or did they print it out of like ABS?
ABS.
Yeah. That's not a property of the design. So what can you do just with design to make it better? You know, like how can you compete with guns that come off an assembly line on affordances? Because it's not going to be durability. And now like access and cost aren't factors if you're just thinking about affordances. You have to target things that you have to target better ergonomics. You have to target innovative things like, you know, the stipples or just like crazy stuff that manufacturers would never do. Like, you know, people laugh at like the Glong and like meme guns like that, but they're actually incredibly important and demonstrate like actually pretty advanced product design thinking because they're actually doing something that you can't do with
injection molding.
gun.
Yeah.
Well, just
without lots of lots of cost, and it's something that would never actually happen.
Yeah, exactly.
In a commercial environment.
Exactly. So like these things seem like tangential to like the mission of like 3D printed guns, but from like a product design perspective, they're actually really the only thing that matters. Like if you're thinking like how do you design 3D printed guns, they're actually the only thing that you should be thinking about is what can this do that a store-bought gun can't? Because that's besides weird libertarians, you know, and people who
well, I mean, with a project, normally when you're starting a project, you have a set of project goals that you want to meet. When you're setting those goals, certainly if you are trying to compete with a off-the-shelf gun, trying to make it better is going to be one of those. It's going to be a very high on that list of goals. But I mean, your goals could be different. You could be trying to make it more accessible, or basically more accessible or higher performance compared to off-the-shelf guns. So it's kind of one of those two.
But those aren't product design goals. Those are engineering goals.
Okay, I mix the two, but okay.
No, but that's fine. Like this is like why talking to you is always so interesting because like you and I have very similar like values about this stuff. Like we see things in a very similar way, but we come at at
a very different perspective.
Totally 180.
Very, very different perspective. I mean, here we are using Boolean operations. I mean, those are scaring me.
Like, but here's the thing: like, we can have a high level conversation about like CAD that flies over most people's heads, even though, like, you know,
are you guys getting this? I hope.
Hey,
so.
I'm sorry. I've been totally dominating this, but
I've been letting you talk on this. I think that's an important subject. I think it's a good little piece there about affordances, which is one of Chairman's favorite words, by the way. If you guys didn't know, it is one of his favorites. Not his most, but one of his. Let me make you big again.
We just modified this surface, this entire surface, the most important feature of this gun, just by dragging the curve in this one sketch. And I'll actually pull it back even farther to show like how I actually apply these to frames.
Why don't you open the surface feature up so that people can kind of see the different? I don't know if it highlights it. SolidWorks highlights everything in a really easy to see way.
Yeah, this does too. So let me do that. So let me unroll those back. And I will delete everything up until the surface. Boink. So here's my definitions in the surface. So you can see that it's defined by these 4 sketches.
Yeah. So for those who are totally not familiar with CAD, the way it works in parametric modeling like this, in most cases, is everything is defined by sketches, which are just lines. Curved lines. They can be on a 2D or they can be on a 2-dimensional or 3-dimensional plane. In this case, I think all your lines are on a 2-dimensional plane, right? Yes.
Yeah, 3D sketching sounds impressive, but really it's just 2D sketching with less control.
So it's normally 3D sketching. The only stuff I do, and I have a couple of them, you're just basically mixing different sketches from different planes together just to get the curve you're looking for.
Yeah, it's basically just a compound sketch. Solid Edge has that capability. I never use it because it always seems to break for me.
So I use it very sparingly. Sometimes it just is handy to do that, but 3D sketches do tend to break pretty quickly. But in this case here, all your sketches are 2-dimensional, and you're basically just, the sketches are, you can think of the sketches as being the backbone of the surface. It's exactly the backbone and then the ribs, and then the CAD, the software fills the sketch inside of that profile. And then if you open the
well, here, let me
Yeah.
I'll just remake this surface. So let me delete the surface. So in Solid Edge, it's called like your all-purpose surfacing tool is called Blue Surf. So it's basically, you know, a combo like loft. You know, it's your all-purpose surfacing tool. So I'm gonna select.
That's interesting. You have a special tool just for that.
So I'm gonna select my three. I'm gonna select my three kind of like rib sketches. Oh, and you can blue surf from anything.
So do you not
don't
have? Go ahead. Yeah.
So you don't just have to blue surf from sketches. You can blue surf from
any intersection or line or
yeah, you
any vector kind of. Well, that's
yeah,
the wrong word, but
you can blue surf from any element of your model. So you can run a blue surf like that. You know, if it's geometry, if it can be defined as an edge, you can blue surf from it. And you can mix. So you can blue surf combinations of, you know, stuff that's defined by sketches and stuff that's defined by you know, other elements of solid geometry. So
same in SolidWorks. So do you not have separate like in SolidWorks, the surfacing tool I use for everything is called a boundary surface, and it looks very similar to this in the way it works.
That's the second thing here is bounded. But
So
bounded is more well, bounded has to be closed. Blue surfs can be open.
Okay, so bounded surfaces in
they have to at least have three sides.
Yeah, that's interesting. So in SolidWorks, you can have two sides as long as you can define it.
Right. I know what you mean. So yeah,
it's just interesting that it's different because in SolidWorks we have boundary surfaces and then we have lofted surfaces, which is like a neutered boundary surface. I don't know why they exist. And then obviously there's some more basic extrusion surface tools. But
you were asking how I keep the edges tangent. So
yeah,
it's giving me these little pips on my edge sketches. So I'm gonna say parallel to section and parallel to section. So that'll keep the surfaces tangent at the ends to this plane and this plane.
So you're making the surface tangent to the other geometry.
Yeah, exactly. Or well, more specifically, tangent to the planes that those sketches are defined upon.
Yeah.
So now,
That makes sense. And you can also go perpendicular if you wanted to and stuff like that.
Yeah. No. So yeah, parallel or normal. So or you can do like an auto, like natural thing that's kind of like a you know, auto select, which actually works, you know, most of the time. But generally, if I'm defining like a foundational feature like this, I'm gonna lock everything down. And then we have this control curve here that we're gonna bring in through this guide curve step. And so we're going to select that control curve.
This is a weird workflow.
And you can see that pops it in. So now I have my surface. I'm just going to finish that surface. Okay, cool. So we have this great surface. And now we need to basically apply it to this model. So the easiest way to do that would be this tool called replace face. So replace face is what it sounds like. It replaces one face with another face. So let's try it. Hey, maybe it'll work. So let's select this back face, hit enter, and try to replace the face. Hey, it worked.
It worked.
So we don't even have to do that Boolean operation. But sometimes it doesn't work. Like let's try this front strap. This front strap is made up of more than one surface. So let's select both of them. And then we'll select that that surface right there. Ah, shucks, it didn't work. Ah, rats. Yep. Gosh darn it. I'm flipping, hopping mad. But we have this surface defining this front strap. So hey, let's try to apply this front strap another way. So I'm gonna go straight to a thickening operation. I'm going to select that and I'll thicken it, I don't know, like 15 millimeters. I don't know. It's probably too much.
So a thickened surface, for those who don't know, is once you design a surface, whatever that surface is, you can thicken that surface, and it does exactly that. It takes the surface and then it just thickens it out by how much you define. And that's actually what I use for most of my built-in support I designed for my lowers. I designed the support as a surface, all those nice curves and stuff. That's a surface designed much like Chairman just designed his backstrap surface. And then I'll thicken it out to the thickness that I want. And that makes a very, very uniform piece of support material that, as long as it doesn't get to too steep of an angle, it prints quite nicely. So that's what thickening is.
Okay, so we have this thickened surface, but you can see the bottom edge is kind of like not good. It's not actually subtracting everything. It's not covering all the geometry that we eventually want to subtract.
Well, you probably thicken the surface normal to the surface rather than a particular direction vector, right?
Yeah, so let me, I can just do I can just extend the surface.
So that's you're doing an offset and then a face replace.
Yeah, and I mean, there's a million ways you can do it.
See, all of this little stuff here just seems like it creates so many buggy little problems later, though.
No, but the nice thing is, because this is its own design body,
you don't care.
Well, it's totally separate from the rest of the model. It has no relation to the rest of the model.
So you never have to cut it or worry about those features again, basically.
Yeah, why would you? It's separate. Like, this is its own separate body that I can deal with separately. It's only not
linked. It's only linked to the main body is through its originating sketches.
No, it's not linked to the main body through its originating sketches.
So how are those sketches defined?
Well, I mean, they might be defined from planes that I'm initially grabbing off the main body, but like that's the main body foundational feature, which I'm never rolling back. So it doesn't matter. But I can define them just with, planes that are defined as an offset from, my coordinate system. But it doesn't matter because I'm never actually, like, yes, it would matter if I deleted this like initial protrusion. Like, if I deleted this sketch and rolled back this initial protrusion, yes, it would matter, but I'd never do that.
So does that initial sketch not have any dimensions on it?
No.
None. So no. Where are you getting your grip angle from here?
I'm glad you asked.
Oh, you're using solid edge black magic here.
I am. So let me show you that. So let me.
This is what this stuff just makes my skin crawl. This like referencing. It seems so easy to make a mistake or not have everything. I want. It's witchcraft, guys. I want everything to be under complete positive dimensional control.
Alrighty, so here's an assembly. And I'll just open up a reference file that I know is good. 19. So here's one of my V2 19s. So all of this stuff is in the same assembly. Oh, wait, sorry. All of this stuff is in the same assembly.
And you have a bunch of references. You have a bunch of other geometry in here.
Oh, yeah. I mean, show all. I mean, yeah, I have a ton of different models that I'm taking little bits and pieces that I like out of for reference. Yeah. And the stuff that I take can be actual geometry. It can just be a line here, a curve there. But I line it all up using like the pinholes. And then.
So do you at least use like mating tools to lock the pinholes together?
Yeah, fuck yeah, dude. All this shit's locked down. Like, none of this shit can like drift or move.
Good. I'm just making sure. You never know.
Hey, sorry. I'm gonna go to camera focus again real quick just so I don't dox myself. So I'll show you how I do that. So basically, any Glock model that I make myself, anything that's homemade, I use a common reference. I use a common coordinate system for all of my Glock models. So I can lock these models together just by assembling them to that coordinate system. But yeah, when I'm making this initial sketch, this is probably exactly what I did. So I'm in my sketching tool and it's just my sketch. Oh, cool.
And you just traced out the other part.
Yeah. So, you know, oh, hey, there's my, well, not visually. I mean, I'm using actual, like, so I can use this project to sketch tool to actually grab the exact geometry.
You could, but it doesn't look like you did.
Well, no, because it's a different, I mean, it's a different design. So stuff isn't, you know, exactly in the same place, but like, actually there are places that I did. That's the exact same angle as that. That's
the top is, yes.
That's the exact same line there. I changed this a little bit, but it's coming off, you know, right there. So yeah.
So this is something that in SolidWorks it's set up differently.
Yeah,
I want to say you could do something kind of like this, but it's not really designed for it. Yeah, like I could bring geometry in and mesh it if I wanted to, like separate reference geometry, but it's not. I've never done that before.
So yeah, I'm like, so this is my totally normal workflow. I'm like working with my model, like, and then I can just hit a hotkey and be like, okay, so, you know, am I close to my reference? Am I not close to my reference? Like for this, I don't want to be close to my reference. I'm trying to change the grip angle base, you know, from my V2. So yeah, that's, you know, I know how my V2 looks and feels. So I know that that's a good change from that V2, right? Like that's the type of change I'm looking for. And then, okay, hide it. I'm back to work. So then, hey, look, we have this, you know, design surface here. We have that. And so basically so this is what we were talking about. It's like, hey, where do these touch? That's why it's so robust. It only touches in one place. The sketches don't actually touch this design body. It touches this design body. And then this design body and the main, you know, model only interact, like they only intersect at this one operation. And that operation is just a very, oh, sorry, I'm still in my, am I in that? I'm in surfacing home. Yeah, so they only intersect with this subtract operation. So I'm saying, hey, here's my design body. And I want to subtract this design body. Bada bing, bada boom. And sorry, let me hide the surface so you can actually see that.
And now you have kind of your grip laid out, and ooh, got some holes there. And,
yeah, I got some holes. So you know, so we rolled back to a way earlier feature. So I obviously I obviously changed that at a certain point.
Yeah, that is interesting. It just seems like a very chaotic way of doing it, though.
Yeah, I went to art school, my dude.
Okay. I think somewhere back here in the chat we have the perfect comment for that. It's something about Chairman being it's some art. Yeah, it's an art school reference. So yeah, I think
yeah, affordances.
Yeah.
Well, hey, let me surrender my
okay.
my
let's
stuff,
hop back
and let's take it back to you. Will you give me will you give me 45 seconds to refresh my sake glass?
Absolutely. Go ahead.
Thank you, sir. I'll be right
okay.
back.
All right. So I don't know if you guys captured any of that. That was interesting. So Chairman has a very chaotic way of doing modeling. Way scary if you ask me. I don't think you can hear me. But that's what he does. Let me share my screen here. And boom. So I can do that. I can let's see. Let's go solo layout. And then let's go add to screen. There we go. Okay, well, that's good enough. All right, so and we'll jump into these comments here, guys, in just a minute. And I know you guys had some good questions in there. So this is the latest lower receiver version 4 lower receiver I am working on, AR-15 lower receiver here. And this is all surface, as you can see. And I'm doing this because I want to try to improve the ergonomics and also the support rib and just trying to make everything a little bit more streamlined. So to give you an idea of what we're talking about, obviously, Chairman gave you guys an interesting little overview there of kind of what surface he is and the different ways he's using it. Obviously, we spent like 4 to 5 minutes going into some very esoteric stuff. Probably you guys got pretty bored there, but that's okay. Let's jump back to I'm in my model here. Let's look at the pistol grip. So this right here is the body. By the way, guys, let's if you let me know, put 7s in the chat if the audio is good here. I'm getting a little bit of reverberation. I don't know if it's good or not. So let me know. Stick 7s in the chat there just to verify our audio is good. And Odyssey, if you guys on Odyssey would put some 7s in there just to let me know it's working over there as well. I don't know if it's too loud or too quiet. Looks like we're good. Looks like we're good on YouTube. And we got Vega. Looks like we're good on Odyssey and YouTube. Okay, perfect. Thanks, guys. Perfect. Okay, so hopping back over here into SolidWorks real quick, we are looking at we're gonna look at how I design the pistol grip. So the first thing I have this lower body right here. I have an area where I'm going to attach the pistol grip. Obviously, I have this cut out area. How I got that was an earlier step I had to work up to, but then the pistol grip itself is, let's come in here. The basic body of the pistol grip is defined by this one surface right here. It's a boundary surface, and it's defined by a few different sketches. So I'm just going to back up those sketches, bring this down, and I have a.
Sorry. I thought I was still backstage for a second. Sorry. I'm just watching.
No. Okay, yeah, no, you're there. I'm trying to figure out how I can single me out. I don't have it set up super well on my end. I have to try to figure that out. Well, that works right there.
Oh yeah, there you go.
Perfect. Yeah, I had to find the right selection. Okay, so the pistol, I have a whole bunch of, let me just hide all this other stuff here. I have a bunch of stuff I was working on. I've exposed. Okay, so just the basic grip body is what we're looking at right here. And I'll even hide this. Right. Actually, let's not hide that. Never mind. Okay, so this is the basic pistol grip body. So what I did is I have right down the middle on the center, I have a plane right down the middle of my part. Right on that plane, I've drawn the basic sketch. It's this sketch right here. And this sketch, and it is fully dimensioned.
Oh, you really dimensioned the hell out of that stuff.
Okay. It's fully dimensioned as necessary. And this has all of the I can tweak everything here really easily. I don't have to drag anything. I can come in here. I can tweak angles. I can change how much this toes in at the bottom here. So this is the basic front end and back end profiles for my pistol grip. So obviously this is the profile for the back strap, and it's just got this this curve right here. This is the profile for the front of my grip, and then up above we have this curve right here, and then this little curve over here on the front end are for the second surfacing operation, which connects the grip to the lower body itself. And this is kind of the backbone of the grip, so to speak. And then if we hop out of there and we jump into our other two sketches, these are kind of what you could think of as the ribs of the grip. This here is the bottom, and this is also just a spline. This is just a spline that defines the curve of how I want my grip shaped.
What's that 0.550 dimension? What are you even referencing towards the center there?
That's the center plane. This is referenced off the center plane.
Oh, okay, gotcha. No. But what? Like that isn't a point on your spline. What's it?
Okay, so this is a style spline. So the style spline is defined by these tangent construction lines. You see these tangent construction lines?
Yeah, I see that
over here. Yeah, so I'm just defining the construction lines, and the spline kind of sits tangent to those lines. Obviously, this is a 5-point spline, so it's not actually tangent to the two intermediate lines, but
okay, that makes sense.
Yeah, it's a style spline. So there's a few different styles of splines. This is the one that's the least buggy and the easiest to work with, I found. So this is the one I now use basically for everything, unless I need like some special matching the curvature to something else or something. But for most work, that works great. And then I add another support rib to the top end up here. And not a support rib, basically just another rib to form it. And this is just another spline, and I can change the shape if I want. I can make the front end. Yep. Go ahead.
In solid edge parlance, we would call those guide curves. So you're connecting, like you have your construction, sketches that control, like, hey, the surface is going from this curve to this curve. And then the guide curves guide the surface kind of along, going between those.
Okay,
two
sketches. I'll show you the tool in a second, the boundary surface. But basically, you have surfaces that run one way, like the x-axis surfaces, and then the y-axis surfaces. That's not what they call them, but that's basically what it is. So I just call them.
So with this tool, could you have a third guide curve in the middle?
Oh yeah. You can stack up as many as you want as long as they all meet at the end.
Would that make it two separate surfaces, or would that still be one surface?
One surface.
Oh, okay, cool. Yeah, that's pretty much like how Blue Surf works.
Okay, yeah, it's they seem to use different terminology basically. I'll open the tool up in a second. So that's basically the ribs, and then you can see I've added another one of these kind of backbone curves right here. And this curve is just based off of I put a plane in there. There's a plane right here, and this sketch is just built on this plane I've installed. And this plane is dimensioned off the other sketches. You see there's a line right there. This line in my primary sketch defines that surface, and then I've drawn this sketch on that surface, and this sketch kind of defines how much the grip bows out on the sides. So this is kind of the same as the front and back curves we looked at originally, except this is a side curve.
Yeah,
and I'm basically just using these curves to make a bounding box of sorts of where I want my surface to be. And then when I actually use the surfacing tool, it fills in. Let me bring down to the tool. Just a second. There we go. It just fills in that box and smoothly connects all of those curves, all of those sketches together to actually make the surface. And I'll open up that tool, edit feature. And
okay, so yeah, there we go. Normal to profile. Yeah,
it's all
exactly.
All basically the same thing. So you can see here I have direction 1 and direction 2 over here on my in the tool itself. So direction 1, in this particular case, I have it set up. Normally, I'll set direction 1 up as like the ribs. So I have the top and bottom here, and then the lines that connect those ribs together are what I use for direction 2. But that's totally arbitrary the way I do it. It doesn't really matter. But what you're doing, the way this tool works is in direction 1, I'm just putting in all of the lines going in one direction, and then direction 2 is just the lines that kind of connect those lines together. And you can see I've got the top and bottom lines right there, the curve, the sketches, and then under direction 2, I just have the front, the back, and then I have the side right there, and it just fills them all together. And then, as we mentioned, let me turn my camera back on. It's gone to sleep for some reason. Looks like Chairman has some extremely active dogs in the background. They're actually, they're super active dogs. Wow. I've set this up right here to be normal to the sketch. So the curve comes down and meets the sketch on the sketch on the back strap right here and on the front area. And I've just set it to be normal to profile. So it's just normal to that sketch. What's interesting in SolidWorks is I actually can't set that. I can't set that to be parallel or tangent to the surface that the sketch is drawn on. I actually have to have a surface there in order to make it tangent to. That's something that's interesting. I don't have that feature in SolidWorks.
You know, I don't know if that's necessarily the case, because you're fully constraining your sketches with like dimensions. So it might just be that.
I think that would make a difference, though. I mean, it gives me basically my options are I can make it normal to the I'll show you in a second. I can make it normal to the profile, or I can make it have some relationship with the surface that it's meeting with. And when I connect to the lower body, I can do that. But in general, if I'm connecting to a sketch, I can't tell it to be parallel, or I can't tell it to be tangent with the sketch, as in the context of the surface that the sketch is drawn on. I have to actually have a surface there for it to be tangent to. I can't just randomly say it to be tangent and it'll just jump to the tangent level of that sketch. That's something interesting.
In this sketch, it makes perfect sense because...
Well, here I can't, because the way I have it defined, you couldn't do that. Anyway, it would fail. But in other sketches, it's not an option really either. I just thought that was funny how they have that separately done. Now, one other thing here with surfaces. So I think most people can see how I have these surfaces set up. And I think it's pretty straightforward, actually. Once you know what you want to do, you're just defining the kind of the back, bit, bone, and ribs. And then there's some other functionality, like in SolidWorks, I can adjust what they call the tangent influence.
Huh. That's a new one to me. I haven't heard of that. So what does that control?
Basically, it's I don't know if this is a poor. I have this surface really well defined, so this is a poor example, but it basically adjusts
how tangent it is.
Well, it adjusts the how much the curvature follows that particular curve throughout the surface. So if I don't know if you'll see it here. If I take
No,
this all the way to 0,
it makes sense. It's how much that
like here,
tangentness.
you can see it over here. And this is one of the things which a lot of people don't like with surfaces, and I see why people don't like it. I don't really have a problem with it, but it's one of those things where it's like, if I bring this down to 0, you'll see the surface over here.
Oh yeah.
You'll see it changes, and basically what's happening there is it's
yeah, I get it. It's how basically how long
the influence lasts.
Yeah, it's basically the gradient of the influence.
Yeah, so generally speaking, making that number larger results in a smoother surface where you get kind of more of an average of all your lines. Like it averages them together and blends everything really well.
I might have to play around with some of my SolidWorks stuff because I like the idea of that. That's a feature I wish I had in Solid Edge. That's fucking cool.
I don't wonder how Solid Edge handled, because it has to handle that somehow. It still has to connect all those lines together and create a surface. So in some cases, if I brought that down to 0, the surface would get like lumpier around the curves, and it wouldn't be super smooth because it's not taking that influence and stretching it far enough. The problem with that factor is it's like totally objective. I'm just dragging it and looking at it, and I'm not even sure exactly what it's doing. I'm just looking at the surface and looking at the result.
Yeah, when I get that classic, like, oh, like I ended up with a lumpy surface, I just have to like redefine and add like different guide curves. I don't have like
I still have to do that.
Yeah.
I still have to do that. This just can help. This can help work that out somewhat.
Yeah, that's like I get it. Like I get why that's fucking cool.
So you don't have that in Solid
No,
Edge.
I don't have that. I don't
do it. Okay, so this is what's weird. So Solid Edge, you have like this weird blue surf tool.
Blue surf fucks. Don't call it weird. Blue surf fucks.
Well, it's weird because I in SolidWorks, I have a list of very concise tools up here, surfacing tools. I have the boundary surface tool you just looked at. I also have the lofted surface tool, which
I have loft, and I have boundary, and boundary works the same way. But like, okay, draw just like take like 3 sketches with no guide curves.
Just sketches, like just sketches. I don't know if let me. I think I have
just 3. Like, can you just do this with like random edges? Like, just take your boundary tool and just like.
Let's see what we can do. Boundary tool. I'll try to go.
So just single sketches. One and then
go to that guy, and let's just. It should connect them together. Let's go flip connectors. Yeah, see, and there's the surface. That's the boundary tool. It doesn't have, it just takes those and puts them together. And I don't even have to have anything in the direction toolbox. I can generate that surface and boom, there's that surface. Obviously these are just 2 straight edges and it just connected them together. But it seems to me that it doesn't require a fully bounded surface.
Yeah, it doesn't.
I don't know why they call it boundary surface. It's a weird name, but it doesn't, all it requires is just something to work with, and it'll put a surface there if it can actually get a valid surface geometry. So it seems super.
Bounded surfaces and blue surfs work differently in Solid Edge, but I
can't. It might be something. So it might be equivalent to the SolidWorks filled surface. So a filled surface requires the surface to be cohesive. It requires all sides of that surface to, even if it's a 3-dimensional sketch, it'll take up. If you have a sketch that looks like a potato chip, as long as it's defined on all sides, if I use the filled surface tool, it will fill that surface and create a curved surface inside of that.
Okay,
it has to be a closed sketch. So
hold on a sec. Give me focus.
Let's make you big here so we can see this. Let's go solo layout. There we go.
Okay, so if I want to make if I basically want to like fill in like down here to up here and like kind of like just that, I wouldn't want to do that, but let's just say I want to do that.
Have you been downgraded to 420 or 360p?
That's just you. I'm still seeing it fine in StreamYard. It's looking.
I mean, I'm looking over at YouTube and it's fuzzier than it was a second ago. I don't know if it's jumped or something. It looks better now. It looks better now.
Okay.
That was weird.
So if I'm making a bounded surface, or sorry, let me start with the bounded surface tool. So I select one vertice and then another vertice, and it's like, yeah, they don't form a closed loop. So in Solid Edge, the bounded surface is for working with closed loops.
I can see the symbol there that you're looking at in the bounded surface tool. How much control do you have over that surface. Like, so it sounds to me like
I can add guide curves in the bounded surface.
Okay. So,
like
so
if I wanted to like add like let's say
let's say you wanted to make a dome. Let's say you had like a disc, you wanted to make it domed. Could you do that with a bounded surface?
Yes.
Okay, so it sounds like your bounded surface is very similar to SolidWorks, what they call a filled surface.
So let's say I come in here and put a sketch on the midpoint and draw just like a tangent arc. Come on. An arc by 3 points. Why not? That's a great arc. I love that arc.
I have not, I've used that a little bit, but like 3-point arcs are like, I don't know. I've never really found them that handy.
So now I'm going to make a bounded surface and I'm going to select a chain. There we go. And then say cool for that selection. And then I'm going to select that as a guide curve. Yeah.
Okay. Yeah. I see what you mean. So okay. That's the same tool as the SolidWorks filled surface tool then. They're just so the boundary surface tool in SolidWorks is equivalent to your blue surf tool. They're just screwing around with names. That's all. I see exactly what that is. So you're defining an initial surface by a closed sketch, and then you can deform that as you like with guide curves.
Yeah, more or less.
Yep, that's okay. That's what that is. That's the filled surface equivalent.
And then I can just like space that out, and whoa, that's some fucked up looking geometry.
Yeah, it's a nice little bulge there in your Glock. Very appropriate.
Whoa, no, that's inappropriate, sir. And then just because everything's parametric, I can say hey, whoa, plane step. Let's put that there. Yep. Okie dokie, and then bulge moves. So it's handy. I do use the solid edge bound tool quite a bit, but not nearly as much as that blue surf tool.
Okay, yeah. So the blue surf, I would say, is equivalent then to from everything I've seen.
Makes sense. Yeah, they're so because there's no filled surface tool in solid edge. So bound is blue surf and filled is bound.
What I don't understand, it just shifted over. What I don't understand is the purpose of the lofted surface tool. I found it to maybe be a little bit smoother with the surfaces it generates. Like they're less.
I've literally never used it in my entire life.
I don't use it at all. I've used it a couple times originally just because, hey, I've used solid loft before, so why don't I use a lofted surface? But it has no purpose. It's a boundary.
I can just connect I can just loft curves and blue surfs all day. Like what the fuck?
I mean, you're defining curves with two different directions of sketches, basically the same as in SolidWorks. There's no purpose behind the lofted surface tool, which is I don't know why it exists.
Yeah, what's up with sevens in the chat? Is that like the
sevens? No. So that was an audio check. I told people to put sevens in the chat. Why sevens? That's just the number to use. That's the cool number to use.
I feel like for you it should be 1 in the chat.
Ones is like an inconvenient spot in the keyboard. People's hands are kind of in the middle. Just make them go to the sevens. That's
but I mean, it's hydrogen, my man. We're hydrogen bros.
That's actually H2. So
hydrogen is 1 on the periodic table, my dude.
But in real life, it's H2. There's 2 hydrogens there. So
what's the elemental number for hydrogen?
Oh my goodness, it's it's very, very, very close to 1.
I hate you
I actually
so
don't know.
much.
I actually don't know the exact amount. It's
Wait,
a little bit more.
It's more than 1?
I want to say it's a little more than 1. Yeah.
God damn it! I should have gone to fucking hydrogen school.
Yeah, I want to say a little more. It's I don't know. It's those atomic things are not super. You got to know the gross density is what's important at different pressures.
Okay, sorry for the tangent. Let's go back to your model.
Yeah, sorry about that, guys. We're let me just momentarily. There we go. So sorry about that.
Well, no, it's not sorry for the tangent. Sorry for the normal.
Yeah. Okay. Yeah. So okay. We'll jump back in to something a little more appropriate. There we go. And Okay, so let's respond to some comments. Believe it or not, we're actually over an hour into the stream now. We're like more than halfway through. I was just going to run to 10. So let's go through here. I'm going to go over to Odyssey. That's the chat. That's what we are prioritizing. I cannot highlight hot Odyssey comments, unfortunately, guys, but I can respond to them.
Well, why don't you share your screen so we can see the Odyssey comments?
Exactly. I can respond to them. I actually did that. There's a way of going full screen.
This is my favorite comment that I've seen so far. I'm a Fusion 360. This is all over my head.
I'm curious. Fusion 360 has surfacing tools of some sort, I thought.
Yeah, they just fucking suck. So here's the big thing. So here, like, I call it like real CAD and fake CAD. So like CAD has been around for a fucking long time.
It's a stupid, like 50 plus years kind of a thing. It's just,
and it's actually like there's CAD software out there that's an unbroken chain of software development for 20, 30, 40, 50 years.
Seriously, it's so ridiculous. It's not even funny.
So you have these programs like CATIA, NX, Solid Edge, SolidWorks, to some extent actually Autodesk Inventor, that's all I can think of off the top of my head. But you have these like programs that are real CAD that basically, and they're buggy as hell. Like you get problems, but you also get like extreme capability. Like you're using surfacing tools that have been refined for a very long time. You're using tools that.
So I feel like somebody needs to take all these tools, port them into a new program from scratch.
Honestly,
spend 3 years working on it, fix all the bugs, and then let's run it on our desktops directly from the machine language, no operating system.
So not machine language, but I've been playing around with it. I haven't really done anything serious with it yet, but I have been playing around with Iron CAD.
I've heard of it,
and
they make a lot of outrageous claims.
So far, it seems pretty good.
Is it parametric?
Yeah.
Oh, really?
It actually seems like a fucking like real competitor. I'm very interested.
I had to look at it. They've been advertising a lot on a little while ago on Twitter, actually.
I actually saw. So I heard about it from some of like my vendors and like my work life, and they were raving about it, and if my vendor is raving about a software package that costs half of what I'm already buying from him, like I know it's probably pretty good.
Yeah. So
no one likes to sell themselves out of twice the commission.
Now, what does it? Yeah, I should. I've seen it advertised. I've seen like I've seen it used. Let's see. I haven't. No, I've seen it advertised, but I haven't really looked into it in great detail. That is interesting. Does it have similar surfacing tools, or is it quite unique?
It's very similar to Solid Edge and SolidWorks. It's just kind of like, have you ridden in like a Tesla is a bad example because I actually don't really like Teslas, but like
I haven't.
But you ride in one and you start using the stuff and you're like, oh, like they built this from the ground up recently, like. Well, yeah, it might not be all there. It might not be 100% of the way there, but like it's pretty much there. And like
they're trying to start fresh, eliminate all the old problems, and like and basically do a full reset of
they're basically
the entire system.
They're basically trying to do what Fusion 360 did, but in my opinion, a lot more successfully. It's lot like. It's the only like from fresh CAD program that I've seen that actually seems feature complete compared to like Solid Edge, SolidWorks, NX.
What is their licensing setup like? Is it a monthly thing? Can you buy it? Is there a
yo ho ho? I wouldn't know.
I see. Okay. I got it. We understand. But I will definitely look into that. And that is interesting because there's so limited number of good options for CAD available.
It's the only attempt that I try new CAD all the time because like I've met those people who are 60 years old and still swearing up and down that like AutoCAD is the best thing since sliced bread. I'm I suddenly find myself in my 30s. I don't want to be that guy in like 20 years being like, oh yeah, Solid Edge. Back in my day, we had real CAD. You know,
Can any picture Chairman at 50 or 60? It's pretty scary. Yeah, I will definitely look into that. Now you've mentioned it. I saw it, and I just saw like some of their advertisements, and they seem a little over the top, like the easiest to use CAD ever kind of thing.
That's fucking stupid. But I wouldn't.
Don't dismiss it. Okay.
Trying it out, it actually it's the only like new from like, you know, hey, we're gonna like do this from scratch, you know, CAD program that.
How is it is it like more stable?
I don't think I've had a single crash fucking around with it. But I also haven't done like serious stuff with it. Like
you haven't pushed it yet.
Yeah, I haven't pushed it yet.
I will definitely check that out.
I've just been fucking around with it, but it seems to have all the features that like I want in like a modern CAD program.
That is interesting. I'll have to check.
And I mean, there is something to be said about getting away from like the legacy code base.
Yeah, and I think that's a huge. The legacy code base is a huge problem. I think because you're dealing with problems that are like just deeply nested inside of decades worth of buggy software.
Exactly. But like the problem is like everyone who's tried it so far like hasn't gotten like the feature completeness. So I'd rather like have the features that I need and put up with the occasional crash. But if someone can give me the best of both worlds, like I'm not a fucking like Solid Edge boomer. I'm not going to live and die by some fucking like German multinational fucking like company
corporation.
That like doesn't, give a shit.
Yeah. No, that's a good way of looking at it. I am very, very much not loyal to SolidWorks just because, well, you know why. It's very unstable and I don't like the company and many reasons. So I am open to other. I'll definitely look at IronCAD. I'm very interested in other alternatives. I wish there was more Linux. I wish there was more Linux alternatives, which would be interesting. Not having to run on Windows, but there aren't. Honestly, they don't exist as far as I can tell.
I couldn't fucking care less. I know people are like, people are mad. Like people get mad at me that I'm like, yeah, I'm just gonna use Windows for everything. But like,
well, I use Windows for everything because it makes the most sense. But if I could use a more stripped down, a more optimized operating system, which Windows unfortunately is not, I mean that would be better. I'd have better performance. So that would be nice, but it's just not an option, unfortunately.
This is the only consumer Linux product that's actually running desktop Linux that I've ever purchased that's actually been good, and it totally fucks. Like, if Valve can save Linux and like get software support actually working, I'd love to fucking switch from Windows.
Mm-hmm.
But like,
yeah, it's very much not a user intuitive thing right now.
Well, no, but it's not just that. It's just like, hey man, like I'm not a system admin. I don't do server
exactly.
stuff.
That's what I'm saying. It's not super user, and that's my problem with it. I'm not a computer guy at all. So
well, no, I'm just saying like I put food on my fucking table doing CAD, which is all Windows. So like I'm not gonna take a principled stand on my fucking operating system choice. And like,
well, it would be more of if it was an option, it would be more of a performance choice. But it's a moot point because currently there are no good non-Windows CAD programs out there.
There is not a single native Linux CAD program that is any fucking good since NX stopped supporting Linux.
Yeah. Yep, which is I mean, so Windows is really the only option right now.
And I use Linux a bunch. Like we have 2 or 3 Linux machines in this house. My wife and I both use Linux Ultrabooks. Like I have Linux chops, people.
Chairman trying to walk back his Windows shilling now.
This is my daily driver for like 7 years. Fucking X201 Linux machine, like no fucking trackpad, clip mouse only. Like I use Linux, people, just not for fucking CAD because I'm not stupid.
Yeah, well, I mean, you don't really have the choice. Okay, so to jump into these Odyssey comments, we have some gooder ones here. So miscellaneous thangs for now says good stuff. Could this be done in Blender?
No.
Or can the end result be done in Blender?
Yes.
Is that different or is it an equivalent class in Blender? So Blender is a mesh based system, which is completely different, and it's completely different. It's
the way I describe it to people who
it's
are new to this.
Working with clay rather than like working with saws and tape measures.
So, most people are familiar with like vectors when it comes to like an image file. Like you download a logo offline and it's like an SVG or something like that. And you can keep zooming into it and it never gets pixely. And that's because it's made out of math. Like those, shapes are being defined as like circles and curves and math. A JPEG is defined as a shit ton of pixels. Like you zoom in on any picture and
the brute force method.
It gets pixely. Like Hoffman is looking a little pixely on my screen right now. That's because he's made out of pixels. You keep zooming in and it's pixels. So a mesh-based model is pixels for 3D modeling. Like they're triangles, not squares, but it's the same concept. There's an actual resolution and it's like made up of, pixels. The type of modeling that Hoffman and I actually use. So like what you'd get from like a step, something like that. It's called NURBS modeling. And I have no idea what NURBS stands for. Do you? I'm probably sure you.
No, seriously. I have not a clue. I have no idea how the back end works.
But
it's very clever whenever it is it, but it's
it's made out of math.
It's based on everything is mathematically defined.
Yeah.
All your curves, all your positions. So that makes it so that it's much more repeatable. You can do actual precision parts with it if you choose to do so. With mesh-based modeling, you're just basically imagine working with clay with your hands, kind of a thing. I mean, you can add in some precision geometry, like the system can generate things like cubes or spheres. That's normally a feature, but it's completely different. And would it be possible to do a Glock frame in Blender? It probably would be, actually.
Yeah, I mean, but talk to Phil. Like he makes great frames just working in meshes, but
yeah, it's not fun though. I maybe he finds it fun. I don't know. I wouldn't find it fun. It's really hard to change things later. So the answer, short answer is no.
Yeah.
Now, Vega Holdings does say down here in response over on Odyssey, let me make Odyssey big again, that there is a parametric design plugin for Blender. I have no idea what that looks like. Sounds scary, but I mean, maybe it's worth looking at just to play with. Coming down. Let's see.
Blackslide, your broke ass has the Pirate Bay, my dude.
Blender. Black site. My broke ass has to use Blender law. So Chairman says to sail, on the ocean, and not the ocean you're thinking of, not the odd ocean. Okay, so we have our sevens in the chat. Oh, sevens, how appropriate. Oceans and sevens. Okay.
I fully endorse piracy for expensive CAD systems.
That's not legal advice.
100%. That is everything I say is legal advice. Fuck you.
Okay, so let's see what other good comments we have in here. I spotted a couple. Be free or die trying says CAD has been around since cardboard. Okay, that's
cardboard aided design. I love it.
Okay, yeah, that's nice. That's a good perspective on things. Okay, let's say more. I think here's more of a design question from Marcus Aurelius. Have you pronounced that? He says, you made the lower and pistol grip on the Orca one solid piece for strength and durability reasons. Were there constraints unique to the Orca that made this idea, or in your opinion, would all 3D 2A prints with pistol grip configurations benefit from consolidating going forward? So what he's asking here is an integrated pistol grip on AR style type lowers better than having it separate? I would say yes.
I completely agree.
So customization, I mean, there's some arguments against it, but strictly from a structural perspective,
there's no arguments against it in 3D printing because you can
because you can customize it yourself. Well, but that's not if the designer only, like me, for example, I only released one Orca.
Yeah, but you released the steps. Like
and the native file, so someone could go edit it, but they can't just someone off the street who has no CAD modeling skills or anything can't just go grab a different grip they like, print it, and use that.
Yeah, but sure, but they couldn't make that grip they like either. So
no, I agree. Yeah, so I think that's a very minor detraction. and the advantage of strength and the ability for the designer to improve ergonomics over the constraints of a standard.
You can do a lot more molding it all together.
Yeah, a standard AR grip, just the way it attaches is actually kind of sucky for ergos. It's like your finger rest position is way too low. For one
yeah,
thing.
It's weird how the AR was so ahead of its time on ergos, and yet there's so much more you can do with just like where your hand actually attaches to the gun. Hey, give me 1 sec. I'm just gonna refill my glass.
Sure. Yeah. Okay. Let's hop through those. So the answer to that question is yes. I think actually integrating the grip is better. Does it make support material a little more complicated? Yes. But with the tree supports now available in most, actually basically all slicers, it's not a problem. A little more support material is really not at all a detraction. So I think, yeah, I'm going to be doing it from now on. Moving forward, I'm integrating all my grips. Just strictly, I mean, structurally alone is enough, but improved ergos is also an improvement. Let's see. Miscellaneous thanks for now says, I'll be 98 years old in 3 days. If that's actually the case, that's pretty impressive, especially if you're on Odyssey. That's up there. So that's pretty awesome that you're here. And he said, I used pre-Sage Cape Cod system, and it was the very best. I assume that's some sort of a CAD system. I'm not quite sure. If you want to clarify a little bit, that would be interesting. Let's see. Bigfoot Goes Boom has another design question here. It's how do I install the safety detent spring with the grip being implemented into the lower? Yes, this is the other downside of using integrated grip. I simply use kind of the brute force inelegant method. I use a screw coming in from underneath a set screw with a hole, and I simply push the detent spring up from the bottom and put a set screw in to keep them in there.
I thought that was a good pragmatic solution. I really like how you implemented it.
It works, but it does kind of have that ugly hold on there, and it doesn't really get in the way of ergos, but it's kind of a little bump. You can feel it.
It's much better than how the
what would Stoner do integrated.
Yeah, because
okay, so I kind of don't necessarily agree that it's better. So the problem with the way they did is they dropped it in from the top, and then you like popped the safety in over it, and it's a permanent install.
Yeah, I really don't like that. It fucked me up.
Yeah. So that is a terrible pain. It's super elegant. Like if you're building it permanently, like there's no exposed holes, and that's kind of cool. With the Orca, I actually can't do that because of the geometry. I mean, I could kind of, I could add it would be hard to do it on the Orca.
I'm a big fan of pragmatic design solutions.
Pragmatic. Do you want to expose on that word a little bit? Exactly what you mean with that here?
A tiny fucking hole isn't a big deal. A non-removable part in a modular platform, which is what the AR has become, is a big deal.
Yeah, it's a big, that's why I consider that for like 5 or 10 minutes, and I said, oh, I can't go with that. I think that it could be cool for certain guns, maybe certain builds, but it's for especially for something that's 3D printed. It's a bad option.
No one will ever fucking notice it. You hand that gun to someone, no one ever notices it.
That is true. Nobody notices.
You take photos of it, no one ever notices it. Like you know it when you build it, or you literally.
I see that all the time.
Yeah, but like you can't let your own autism get in the way of like pragmatic design solutions.
Yeah,
like I think sometimes the best solution is the easiest.
In this case, this was the easiest kind of brute force set screw solution, and it does work really well. The threads are you can print the threads into the part, no problem, just using 0.2 layer heights and a standard 0.4 nozzle. So I think it should be an integrated grip would be a benefit. Really, I think anything that uses an AR-15 fire control group, an integrated grip would help. Obviously, like probably the biggest user of integrated grips, kind of commercially, is either it's probably HK. HK loves their integrated grips.
They do.
Yeah. Now they didn't do a very good job with it. I don't think they kind of like, but they were like the biggest user of it. And I think it makes a lot of sense for plastic, especially 3D printed parts. It makes them a lot stronger. Okay. So we have a couple more comments here, and I'll jump into kind of showing people kind of what I was doing with my lower. And let me bring these up. Let's see. Okay. So it was another question. Oh, right here. Pimp Hand Strong says, have you seen Plasticity yet? I saw an ad the other day and it piqued my interest. Price is good, no subscription. Plasticity
I've heard
as
of it.
it sounds to me like a mesh-based thing.
No, it's actually guess who they licensed the kernel from.
Same as SolidWorks and Solid Edge.
Yep, it's actually Parasolid based.
Oh, that's funny. Is it very similar?
I mean, I assume there's similarities if they're basing it on Parasolid, but
Why though?
I
Like,
haven't played around at all.
Why do we need a third option based off the same? I mean, there's more than that too.
I mean,
I
if someone wants to try to take what's good about Parasolid and put it out for a no subscription free thing and try to make their money, fucking I don't know how, but if someone wants to try to do that, hey, give it a shot.
Is it? Yeah, I mean, Plasticity. I had never heard of it actually, so it sounds.
Yeah,
like
I mean, hey, they're on Parasolid, so it's obviously a relatively serious CAD program.
How bad could it be?
Yeah, exactly.
Thanks for the explanation. Okay, and 20 on Odyssey. Let's see. Let's see. No Touchy says, wait, are steps editable? Are steps editable?
Yeah.
And yeah, a step file is just a file that has all of your surface geometry in it. It's basically just a bunch of surfaces making a solid. Do steps even have to be solid?
No.
I don't think they do. It's just basically a collection of surfaces. In most cases, they form a closed solid.
So steps are just like a NURBS interchange format. They don't have to be solid, but they do have to contain like valid NURBS data.
Yeah, and they are editable. There is no like feature tree or anything. I never edit step files. That just sounds like something I don't know. Like I don't know. I mean,
yeah,
I customize little stuff on somebody else's design, like little ergo stuff or something like that. I can understand using a step file, but it just sounds like a kind of a dirty, unpleasant thing to do.
I like step files a lot. I use them quite a bit for like I'm using Neutron Nick just made a great design for it's just another block, but he I listen to P80 Ralph. He lives, I mean, you met him when you were down here.
Yeah.
I mean, he lives like, very close to me. And,
yep.
I wouldn't take his advice on Twitter, but I'll take that man's advice on Glocks all day. And,
yeah, seriously. Yeah. But he has some pretty nice.
Yeah. He really knows his stuff. So, he says this Neutron Nick, file is the best, easiest to assemble, workingest 3D Glock file he's ever seen. And I talked to Nick, and he's like, yeah, feel free to use it. So I'm looking at potentially moving over to P80 Rails for my next V3 iteration. And yeah, so I mean, I can just grab that step file, I can orient it in my assembly, and I don't have to directly use it, but I can grab any surfaces, bodies, edges, just anything off it. And that's by virtue of it being a step, not like, I couldn't do that with a mesh file.
No. And mesh files are kind of like the very last. Mesh files is what you plug into like a post-processing program, like a slicer. Like it's like the very, very end of the production chain before you slice it.
Yeah, it's like if you're working in like Photoshop and like your final output is a JPEG, but
just before you upload it or whatever.
You're not saving that JPEG out a million times and like working on it.
No.
It's your final output.
No, exactly. So that was the rest of our Odyssey files. Let's hop over to YouTube, Odyssey comments. So we have a Tempest Adverse said, what software is Chairman using? I think we've been talking about this, but you're basically using Solid Edge.
Yeah, I'm a Solid Edge boy. I'm a weird boomer. Don't worry about it. Yeah, just use SolidWorks like a normal person.
But an interesting thing to note, though, is Solid Edge is available for free personal use. Download.
It is now completely free, and there's no like it's a fully featured version for completely free,
which is like a huge opportunity because SolidWorks does not provide that.
And I mean, Solid Edge is fully featured. It is as fully featured as SolidWorks. I personally like the workflow better, but that's a personal preference thing.
So if you are looking to start learning a more advanced CAD program, definitely just checking out Solid Edge. I mean, there's a direct link on Chairman's Twitter page.
If your whole thing is, I don't want to break the law, which is kind of weird in this space, but I mean, I don't break the law. If you don't want to pirate software, and your option is free Fusion 360 or like student or whatever community, but you still pay for it, SolidWorks.
Go Solid Edge.
Yeah, go. I mean, 100% go Solid Edge.
So that is now available, and that is, I mean, I think it's been available, and that's super cool because that they have that. So
I tried to get Siemens to like sponsor me a bit or like send something my way because like I made a post about it and it like did really well, and like just out of for a CAD post it did really well. So I was like, let me search that, and like the most liked post in all of Twitter history about Solid Edge was like maybe like 30 likes. So I was like, hey guys, I'm your most popular Solid Edge influencer. You want to like
you want to say your way? They didn't get back, did they?
No, they never got back to me.
But. No, that's classic big
competition. Well, they're German,
Yeah, exactly. What more do you expect? So Logan here says, I design daily in SolidWorks using solid bodies. What's the best way to start learning to design with surfaces? So basically, you need a reason to do it. So if I don't know what you're designing, but if you're designing something that is has a need for surfaces, then just start using the surface tool. Like if you're using lofts right now, I used to use lofts a lot, which is basically
when I first started, I used lofts a lot too.
Yeah, I use like my pistol grip.
I don't think I've used a loft in years. Surfaces are pretty much always superior to lofts.
Yeah, exactly. So I'm not using lofts anymore, but I used to use lofts a lot. And a loft is just a closed surface that the program can turn into a solid.
Yeah, it's just it's just surface modeling with extra step. It's just less reliable surface modeling.
Yeah, exactly. And if you're already using lofts, you can start substituting surfacing. Just go in. You probably don't even. I don't know if you probably don't even have it out on your main SolidWorks dashboard, but just go to your customize, search for the boundary surface tool, add it to your dashboard, and then just start playing around with it. And once you kind of understand how it works, like we've been showing you here, you'll definitely start to you'll start seeing places you could use it and then just start implementing it. And that's basically, I mean, that's probably the best thing for you to do to start learning how to use it.
If you're a real cool guy who's using Solid Edge now, like Kyle over here in the YouTube comments, you have a whole dedicated surfacing tab. It's awesome.
The way so SolidWorks does that too with tabs. I don't like the tabs. I have all my tools, like my primary tools, they're all lined up right there. No tabs, like they're all on the top of my screen all the time.
You fucking weirdo.
No, they have tabs. I've hidden them. They have like the different like toolbars. They call them like they call them the command manager in SolidWorks. Like, no, thank you. Okay, let's see what other things we have here. Let's see.
So I've been trying to get all my Mexicans to start using trackballs. So I have this whole like department now, and I'm like the head of this department. So I figure I can like, basically just like implement my technology like preferences on these people, because like I'm really good at technology. Like these guys aren't. So, and I'm their boss now. So maybe I should like, if it's good for me, maybe it'll be good for them. So I'm really trying to get people to start using trackballs because, I don't want people to get carpal tunnel.
Exactly. And how are they?
It's not going working? Well. It's not going well.
It doesn't. These people don't get it. I don't. Yeah, these people. I mean, I think. Oh, my wire's not long enough. I don't think I can. There we go. Yeah,
you're doing it.
Oh yeah, I've been using this for like a year now. Whenever this is the one I'm using. I'm telling you though, my thumb ball is still better. I am giving this the long. I do not have the angled thing yet.
Okay, I will send you the file right now because you have to have the angled thing and you have to have one of these.
There goes my battery. I will change that in a second. Yeah, so if you send me that, I will print it up and use that, and that'll be good. Okay, so
I just printed a new one to take to my workstation in Mexico, and I'm refurbishing my oldest ball right now to
clean it up and everything.
Well, just to leave it down there because I've had this one for 10 years.
Oh wow, yeah.
So
it's been around a long time.
Oh yeah, the L tracks. I mean, they're
like the
old.
90s.
They're old as dirt. But yeah, I've had this one for 10 years, so I figured, hey, might as well just buy another one for at home, and I can take this old one down and leave it at my Mexico workstation.
Yep. Yep. Okay, so you can. I set you as. I don't know if you have signed in as an administrator. I sent you that link via an email. I don't know if you saw that, but you should be able to highlight comments from your end. So see if
you know
can.
what? I accepted the administrator, but I never.
Whoops. Can you guys still hear me? Oh, yes, you can. That was just, I think, Chairman stepped out. Okay, guys, I'm going to be gone for just a second. I'm going to grab my new battery. I was hoping that Chairman could answer the comments while I was gone, but this will just take a second. He'll figure his end out. Okay, let's see. All right, so I'm back. Let's add Chairman back to the stream.
So yeah, it turns out logging into StreamYard kicks you off of the stream. But can I highlight comments now?
Give it a try.
No. That's probably 100% on me. I probably just fucked it up.
Yeah, you have to like log in and then like make sure you log into your account. It's a little weird. But whoa, we got ourselves some real out there stuff going on.
But I can highlight comments like this. What trackball do you recommend? Rick Fair. It's called the. So
this is very ghetto right now.
You sawed off. So it actually used to have the best name ever. It used to be a company called Clearly Superior Technologies, and their product was called the Clearly Superior Trackball. And so in most circles, this trackball is known as the CST. But they got sold to like a holding company. So I think the current name on Amazon, if you go and try to buy it, is the L track.
Yeah, that's what they call it. Yeah,
I've used every trackball out there, and
this one, I feel though ergonomically could use a lot of improvements. Like it's just this big flat dumb piece of plastic.
No,
90s styling.
You have to tilt it, and you have to have a wrist rest.
I did try it. I did try yours, and I do see how that helps. Like I'm super used to mine now, but I'm going to try. I'll try that. I'll have to readjust to it. But yeah,
it's the secret sauce is having it like that, because it's like a keyboard, right? Like you have your wrist rest, and like it's all about immobilizing your wrist and keeping your wrist comfortable.
Yeah.
If you want to try another one, I don't personally like it, but it's much more like ergonomic. It's called the Elcom Big Ball.
Yeah, I looked at that one. I don't like it.
Oh yeah,
I already looked at it. Yeah, no, my problem is I still think the thumb ball is better. My thumbs have plenty of control, just as much as my fingers, and my hand is more stationary, like totally stationary. The problem is the thumb balls. I tried like some of the. I mean, there doesn't seem to be a good quality thumb ball available. That's like they always get buggy.
Yeah, I mean, I keep a bunch of these guys around.
That's it. I've used those. I love the ergonomics on it. They just get buggy after a while, and they don't respond smoothly. That's
well, yeah, I mean, the problem is these zirconium elements. So, and actually, I've replaced them on this one, but they have just these tiny little ball bearings.
Yeah, just a second.
Usually they're quite shit, but these ones actually, I modified this one with greased steel ball bearings, and changing the ball bearings does make a small difference, but I still think that the CST does it right. The CST bearings.
Okay, there we go.
So the CST has bearings that are engineered like this. So you have actual
rollers.
You have actual ball bearings with an actual steel roller, and
The
it's
problem
all.
is they're still side slip. The ball is still side slipping because you have 3 of those guys. You still have to have side slip when the ball rotates. So it's not perfect. I think it could be improved upon.
Well, if you twist the ball, but if you translate the ball, there's no side slip.
No, there is. There has to be. On the one of them rolls, the other 2 slip and roll. Now they're all polished, so it's not a huge problem. But
Shit, yeah, you're right.
yeah, I think suspending on like cascading ball bearings would be better. I don't know. It's just I think it could be improved upon.
Well, you know what the best one would be? Like fucking like magnets, you know?
Magnets.
Yeah.
Oh yeah.
I don't know how they work, but I think it would be best.
Okay, so jumping back in here, we are really falling behind here in the comments. There's a few more I want to highlight. So Simon Claret comes in here. The lack of dimensions scares me because just the tiniest nudge can completely change the model. I could not agree more. Absolutely. Right here. This is it. This is right here. Need to turn blue lines black. Do they have that in? They do. Yeah, it's the same in Solid Edge and SolidWorks. Yeah, those when the line is fully defined, everything I want fully defined across the board. Then I can just take it and move stuff however I want. I'll do it without dimensions to kind of get it where I want it, and then dimensions go in. Okay, let's see what else we have here. Okay.
I mean, listen, I fully constrain my mechanicals, but the ergos, like that's like free flowing, man. That's like, hey.
We can have fully defined free flowing features.
How are you gonna put a number on like what feels good in your hand, man?
Put the number there and change it. Okay, so Andy likes candy, which is I think the best handle we've had here today. Says Fusion 360 has good surfacing tools. It's much more 3D printing orientated than the others. So that's interesting.
What the fuck does 3D printed oriented mean in a CAD program?
No, so I thought no. There could be tools, a suite of tools dedicated to 3D printing to like analyze overhangs and stuff like that.
Solid Edge has that.
What do you say?
Solid Edge has that. There's a whole 3D print. There's a whole design for 3D printing analysis suite that's built in.
That's so SolidWorks doesn't have that. As far as I must be on the, it's on the more expensive. See, I only have like the standard version. I don't have professional.
Yoho. Oh, well, yeah. You actually run a business doing that.
I actually run a business doing it. Yeah. Okay. So okay. Well, in that case, it's fair across the board. I thought about upgrading, but like, I don't know. I will look at other options first though.
Well, why don't you grab the free Solid Edge edition? And
I already have it. I just haven't.
Drag a model in and analyze it with the 3D printing analysis suite.
I will do that and just to check it out. Yeah, I downloaded it. I just haven't played around with it.
Because it can natively open your part files, so you can just open up the file in Solid Edge and just run the analysis when you're done with it.
Yeah, yep, that would be handy. And like some other sketch tools, like doing sketches that are like having like a predefined whole sketch that's defined that has the proper little teardrop shape, that would be handy. Just stuff like that. Let's see, where was that question? Okay, so I think that's let's see, Richard. Right. Let's see. Let me know if you see a good one. I'm gonna try to scan through here.
So Ron Bear, the OG Microsoft trackball is actually really good. It's one of like the OG fingerballs. It has a very high reputation among trackball enthusiasts, but try finding one. I mean, I've seen them go for multiple hundreds of dollars. Just get into the CS if you want the best fingerball, get into the CST/L track. Put it on a 3D printed riser. Get a wrist rest. I mean, that's the cheapest, best trackball, and they actually support their customers. You can own a 10-year-old trackball and your bearings are shot. They'll send you all. And they'll send you replacement parts for the whole thing. Like I have this one sitting on my workbench, my 10-year-old one. Bearings are fine, but I got a little too aggressive with the scroll wheel, so I broke one of the plastic mounting points for the scroll wheel, and I'm just waiting on a new plastic housing from CS, from L track instead of having to buy like a new, you know, $160 trackball, you know, some guys in Missouri are just sending me the part and, you know, it cost me less than $20.
Yep. So Simon Claret comes back with another great comment. AutoCAD is depreciated trash.
It actually still is the best 2D drafting software. Like if you're doing 2D draft.
Okay, I'll admit there are legitimate reasons why you might want to do that, but as I said,
furniture layouts, you know, doing like a factory
layouts, like layouts, building layouts, that kind of thing.
Yeah, like doing like construction factory, like 2D blueprints. Like there's still a lot of 2D CAD out there for, you know, like floor plans is a big one. You do see quite a lot of it, and it's used quite a bit. And
yeah, I can see why you'd want to do that. I mean, obviously not in what we're working with, but there are places where doing layouts is very, very, very handy.
If you're a 2D drafting like professional, AutoCAD, in my opinion, is still really the best piece of software out there. It's just really, it's for what it try, like the 3D stuff they've tacked on to AutoCAD is garbage, hot garbage. The actual like core 2D AutoCAD experience is, you know, once you learn it, it's the best 2D drafting software out there.
Yep, that's interesting. I've never used it, so I don't know. And then one last thing from Simon again. He says you can tell SolidWorks to automatically assign stuff. That's true. You probably don't want to do that. It defines everything off of like a central reference plane and does it in a very Cartesian coordinates orientated way. It's just not pretty. You want to define stuff in the way you want, however that is. Okay, so I think that gets back to most of the highlighted. I probably missed some I'm in here, but I think I highlighted the big ones. We have one here from Nami. I wish more people were working on 37mm designs. Love my NT79 and can't wait for the RPG 37. Yeah, I think they're awesome. The problem is without reliable explosive and fuse trains, they lack practicality. And there's a lot of legality issues with that. So that's kind of the problem with them. It's just the chemical side of it is very challenging. Okay.
I just want to make one more point about the excellence of the CST. This is the CST's ball.
And it's the largest mass in the entire thing.
Well, it's not just that. You know what this is? Do you know what this is?
That is a blue. No, it's not blue. It's actually not blue. It's like a translucent, darkish colored.
This is just the old black one.
Okay. Oh, okay.
You know what this actually is?
It looks kind of like an 8-ball.
It's exactly a billiard ball. These are just billiard balls without legends.
Nice.
So you can take any billiard ball, put it in your CST, and it works. So when I worked in Baltimore and was using a CST, like when it was like Ravens season, I'd throw like a novelty Ravens ball in there.
Okay, that's funny.
Orioles season, I'd throw a novelty Orioles ball in there. People liked it, you know. It was a good time. So you can throw like if you can find a novelty pool ball, billiards ball, you can throw it in your CST, and it's a 1-to-1 replacement, and it's a good time.
That is funny. Yeah, I've noticed that it is that size.
It's not just that size. When they were prototyping it,
they used.
They took the pragmatic approach and said, "Well, fuck it. Let's just use a billiard ball." Like,
and that's
why get a custom sized ball?
Yeah, and it is a nice solid. It's not like one of those little hollow aluminum balls or something. It's a nice solid, heavy. I mean, it does feel really nice. I just wish it was a thumb ball. I wish they took this and converted it to a thumb ball. I feel like I could 3D print a housing almost.
You could.
I don't know. Here's what I don't like. I like the ball on it. I do not like the switches and the scroll wheel. I don't like the way, like my hand has to like hover all the time. I mean, you get used to it, but I don't like, I want my hand to be relaxed.
Wait. How do you touch it? I'm curious about that because I've heard this complaint before, but I think people are
that sounds like a very personal question.
No. So I'm up here.
Same thing.
And coming down. And so like my middle finger. Okay. So you're
middle finger up there. And I'm like right on top of it. And then I move up and down. Yeah. Same thing.
Okay.
And I'm used to that now. I don't think about it, but the problem is, especially when I was starting, like my palm is not super well supported. Like the base of my hand is supported, but like the center of my hand is kind of it's all kind of like floating there.
Yeah, well, that's the angle, the rise, and the
Helps
wrist
with that.
rest. Yeah, a ton.
Okay.
It's I don't even use these anymore without the angled riser.
Okay. Yeah. I will have to. I will print that out. I will get that printed out tomorrow. Okay. So I'm going to do a screen share again. I know it's getting. I know we just burned a lot of time there talking, but that's okay. All right. I'm sure that we're having fun, and I hope the viewers are following along.
My wife is asleep on the couch. She fell asleep watching that new Idol anime, which is actually excellent. But I know you don't watch anime, but I got all the time in the world. My wife's asleep.
Excellent. Okay. So I was going to go over just kind of some of the steps I did using surfacing on the rest of this pistol grip. And then I was going to go over the kind of the whole lower, and it's kind of my thought process. So I've just been trying. I started off with this, just trying a whole bunch of different stuff, like until I'm trying to work out my workflow of like the order in which I want to do things in order to use as few features as possible, or as few features as possible. I want to do things with as few steps as possible, and like as smoothly as possible. So I keep like redoing it, trying to optimize that and make it as robust. So I want to try to make my models as robust as possible so I can go back and change stuff and tweak it without having it fall apart. So that's kind of another big thing I like to focus on. But
I really appreciate that. And I reach similar ends by using like the Booleans the way I do. But like,
yeah,
you know, I don't think you would never abandon that for like the sake of a cool feature. I often like put features on top of stuff where I'm just like, man, I just want to add that.
No, so I'll do that just to try it, but then I will go back and do it right later.
I never go back and do it the correct way.
Okay.
Never.
I can't handle that. That just grinds at my soul.
The bones, like the bones of my models are always, completely correct. But when it comes to like, the refinement and like, oh, I'm gonna add a feature here, add a feature there. Yeah, I just wing it on top of it.
Tack them on. So right now, what I'm doing with this lower is I'm just designing the body of the lower. So there's no pinholes or anything. I'm just designing the body. So that it's just that. It's just the outside kind of the major features that make up the lower structurally. And then after I do this, I'll then cut all of the other features. And that's where I could actually use Boolean operations perfectly acceptably to kind of drop in an already pre-designed piece possibly. But I'll do that afterwards. And once I'm at that stage, if I want to add a small feature, I'll just tack it on top. No problem. But when I'm in like the earlier design stage, I'm trying to get everything else worked out. I want it to all be super stable and consistent and not.
Yeah, I mean, we're completely agreed on that.
Good.
We're doing it in different ways. I like to start with a solid and like use Boolean.
No, that's what I used to do. I used to start, but I'm now kind of moving more towards just kind of ground up doing the part.
Yeah, I see why you're going towards that. It's the right thing to do.
Exactly. It's the right, ladies and gentlemen, or boys and girls, it's the right thing to do. Okay. So this particular I have that half of the pistol grip right there, and this is a really great example of why surfaces are so good for this particular type of thing. So I used to blend my pistol grips into my lowers, and in fact, let me actually bring up an example real quick.
Just using like fillets and shit.
Yeah, let me show you guys. It actually worked pretty good. I mean, I'll bring up.
It's not the same.
No, it's not. And I actually am not totally positive that these ergonomics, I'm going to be happy with them because there's nowhere to like put my thumb. We will see.
Gotta have a place to put your thumb.
Yeah, like I'm adding a little bulge there. It's going to kind of rest. I think we're going to be good. But like, we will see. We will see. I have not printed this guy out yet. I'm still working on him. Let me open up my lower version 5.3 right there. So let's drag this. This is I'm going to bring the Orca in here. So the Orca was done with a mix of surfacing and solid modeling. And I messed that up. Did not want to do it that way. That was almost a big mistake. Let's go. me get the file.
I have been chipping away at your Orca. I took all the internals and I like turned them into a solid that I could just subtract so I can commit heresy with it.
Yeah, I saw you mentioned you were working on that. So yeah, I mean it definitely needs the pistol grip area needs some work, and there's a lot you could do with it actually.
I'm not gonna do a lot. I'm just only gonna do dumb shit, and you can't stop me because you've already sent the files.
Yeah, it's unfortunate. So I do. Did you see? I did release the native SolidWorks.
I saw that.
Yeah, so those are also available. Okay, I just had to reshare a different screen. Boom. Okay.
So the AR had never interested me before the Orca because like
it's boring.
What can you do with it? But now,
yeah, there's a lot. It's a super modular system, which may seem like boring and plain, but it really opens up a lot of options. I'm going to take this guy all the way back. Now, this is a model I'm pretty proud of. This one came out really nice. It's just, look at all those nice, neat, oh, you can't see these neat folders. There we go. Look at all those nice, neat, all my planes, the inside, everything's in its own little categories. This one came out very nicely. Okay, so our pistol grip is right there. So yeah, there's a whole lot of stuff in that folder, but the, let me back all the way up to that loft. There we go. So my original grip was just a loft. So we talked about lofts earlier. Oh, why is it going black when I do that? That's weird. That's weird actually, because it doesn't go black on my main screen, only on StreamYard. So this is a loft, and it's the same. It does the same thing as the surfaces do. It just creates a solid body. So that's the loft right there. And then I used a second loft, and I just dropped a second loft right in here like this. And then I used a fillet to, let's see, I filleted the front end of it. Then I used fillets just to kind of blend it in like that. And it works, but it's not totally optimal. I don't have very much control over like what happens down here. It's just all kind of like just shoved together with fillets. So let's make that small, and let's swap back over to our other screen. Let's go present, and I will show you how I'm doing it now. Share screen. Let's go there. Share. I'll make that big. Let's go. There we go. Okay, so this is a perfect example of why surfacing is so handy. So I want to attach this grip, which is just half the grip in this case, up to this this lower receiver. And I've made this feature right here. I basically kind of blended and cut out my lower receiver to create this opening, which is all tangent edges. So that these tangent edges here kind of match up to, well, let's imagine half of it. The one half here, while it's curved and complex, it matches up to this half here. It's all nice and curved. There's no weird geometry that's not going to match up. That's one thing when doing surfaces like this, is everything does need to match up to create a smooth surface. And in this case, I'm not quite there yet. There's still some little weirdness in here, but it's almost perfectly smooth. So I'm going to show you what this looks like. Let's go there. Let's go show that. The screen is going black a couple times here. I don't know why it's doing that. It's a little bit weird. But what I thought basically done here is I have made those visible. Let's go up here. And boom. So what I've done here is I have selected, just like we did for the grip body, I've selected, except instead of using sketches, I'm using the grip body itself. I've selected the top edge of that grip, not body, but surface. So I've selected the top edge of the grip surface right there. I've selected right there. I've selected the one half of this edge right here. And then I have selected the backstrap area right there for a guide curve. And then down here, I have selected the area right here, right above your finger, as a guide curve. And I've drawn these curves or sketches, which I've drawn in, which are tangent to the rest of the lower receiver. And that is basically all I've done. And then I've set the surface right here, curvature to face. So basically it takes that surface and it matches the curvature of the surface with this face right here, the highlighted face. And if I disabled curvature to surface, I made that none, you'll see it just kind of drops in there at it just kind of wherever the surface naturally comes in, it is where it rests. So the set surface is not tangent to the face at all. But if I go back to tangency to face, boom, now it drops it in, and it just that's tangency to face. And then I want to go curvature to face, which is just a little bit different. It just blends it a little bit more smoothly, basically. Nope, not direction vector. I just messed it up. There we go. And that's basically all I'm doing. So this is an operation which should be very difficult to do not without using surfacing. So this is a great example of why
impossible to do without doing surfacing.
Basically, yeah. I mean, you saw how I did it. I did it on the Orca. I just kind of like mashed together with fillets, and you can get something that works, but you can't get something this well blended without using surfacing.
Well, also you just don't have the control. Like you don't like surfacing lets you precisely go from like transition to transition with
smoothly, and like in a this is a complex curve. So you mentioned before that you never use any tools for highlighting curvature.
No,
you just like look at it. So I use the curvature.
Well, I work at a smaller scale than you as well, so I can also just like print it quite a lot easier. Like
that's true, but I mean, but at this stage in the operation, I don't have anything to print. It's just like some surfaces.
That's true, but yeah, I always have something to print because I always bind stuff to solids.
You cut, you're cutting. You always have a solid. I mean, I completely agree. This will be printed. I have, I have lots of previous guys. I print these out and look at them. I mean, there's no better tool than actually printing out and feeling it with your fingers to see what it's like. But like you can see here, this particular tool in SolidWorks, it just highlights the color is connected to the radius of that particular curve. So red is obviously tighter, and black is zero, is infinite. Actually,
I want to address a comment. Can you highlight Plastic Blaster's comment, the most recent comment on YouTube? This makes me glad I use F360. I'm already lost watching this.
Glad?
My dude, you're talking to the most popular designer of the most popular rifle platform for 3D printing in the world, Hoffman Tactical, and that same guy for the most popular handgun platform. You should be upset that you are not understanding this, because if you want to make good designs, this is the stuff you need to understand.
So take a deep breath and then download Solid Edge.
It's free.
Start experimenting. I don't know. This may have been facetious. I'm not sure.
I don't care. It's not about you're goddamn right.
Okay, yeah, absolutely. Check out Solid Edge.
If we're gonna keep going for a minute, I'm gonna refresh my drink one more time, because
do that. We're gonna go. I was gonna knock off at 10. We'll go a little bit longer just because this is as normal taking longer. But I wanted to just kind of go over a couple more.
I'm here till you're not here. I just want to make sure that I'm drunk so I can abuse chat.
Awesome. Okay, everyone heard that, right? Good. Okay. All right, so that's kind of a really good example. Like if you're wondering what surfacing is good for, this intersection of the pistol grip up to the lower receiver is a really great example. I can very properly blend this in. And what I was highlighting earlier with this tool was, you can see we've got some little surface anomalies because it's trying to take this complex curve up here and blend it into this curve down here. And it's trying to stretch it to make it do that. And that is not always done perfectly. So I need to kind of play with my guide curves a little bit. This is almost perfect. Like this is probably totally acceptable as it is. I mean, you're not going to ever feel any problems there. But I'm going to take another look at this just so I can smooth this out a little bit more, try to figure out what's going on there. But this is a great example of why surfacing is so great for this kind of thing. And then I just take this surface right here and I just use a mirror tool, flip it around there. I now have a complete pistol grip that is hopefully ergonomically proper. I've taken a lot of stuff from my previous design, so this should have a nice radius finger groove up in here. No pressure points. Nice area to rest your thumb right in here, right along there, a nice spot that holds your thumb. So this is really looking promising. I'm really happy with how this is going along. So that's a really good example of surfacing right there. Another example of where I'm using surfacing, and this is something that actually took me weeks to figure out. I'm just working on it. I wasn't sure what I wanted, and I'm still not super happy with it, but it's this new support rib. And this is surfaced, as we'll look at in a second. But I'll go in, and we have a comment in here. Let's see. Right here. North or N Carrie says, what degree angle am I using for my pistol grip? That is it's just a good general purpose question. I have experimented quite a bit with angles on pistol grips in the past. And this guy here is like an 18 to 23 degree angle, I want to say. Let me just bring it up.
It's pretty much correct. I mean, these days you want to keep it on rifle platforms. These days you want to go more towards the vertical, and honestly, even on handguns.
Yep, totally. So too vertical. It's a balance. I don't know. So I always thought like vertical, just feeling it with the way my wrist motion works. Let's bring us up real quick. I always think like vertical is better because like I want to just kind of hold my wrist like vertically, but when you actually try it, it's just not natural. Like a little bit back is good. So I'm using
AR versus handgun is a little different in this regard, especially with Glock.
It is
because it is. Glock magazines force a pretty steep angle. Actually steeper than you would really like to have. So sorry, you can't see the base plate, but I mean, yeah, it's steep. So one of the things you do to make Glocks, and it's just a factor of when the gun was designed.
Yeah.
But they've never changed that. So that's one of people's chief complaints. Like that's one of the things that pushes people towards platforms like the SIG P320.
Yeah. So what is the angle? What is kind of like the general angle on your grips?
You're going to be mad at me.
You don't know.
I don't know.
I thought that would be the answer. So for those of us who use numbers, my grip is between 18 and 23 degrees. There's actually a 5-degree difference between the front end and the back end. I have it actually tapered. It gets a little bit wider as it goes down. So
yeah, I just go entirely by look and feel when it comes to the ergos. I do not put numbers on any of them.
You guys have now seen it. Chairman is officially an artist.
I went to art school. Like I don't know what you
that's no excuse.
It's actually like, dude, you know what I originally went to school for? Did I tell you when you were here in San Antonio?
I don't think you did.
Glassblowing.
Glassblowing.
I originally went to college for glassblowing. I was a prodigy glassblower as a high schooler.
Glassblowing is a fascinating subject. I actually tried it once unsuccessfully.
Not like blowing like the tiny stuff, like little like pipes and like shit like that, where it's like that's like tabletop work. Like actual like Venetian glass blowing with like the iron rods,
giant ones.
As long as you are tall.
I don't know why you didn't mention that. That's like big news. That's really cool.
It was a long time ago.
Oh wow.
You know I had to get out of it?
Why?
I couldn't stand the heat. There's a big difference between doing it a couple hours a day, after school, and doing it, 8 to 12 hours a day, all fucking day. I literally couldn't handle the heat.
I understand that. I was doing a little bit of foundry work myself in the past. I do understand that in both the physical and metaphysical sense.
But yeah, this guy just nailed it. Andy likes candy. Chairmanwon would love it because it's all freeform mesh. Yeah, that explains a lot about my approach, Yeah,
that is interesting. Yeah, I don't know. I like things fully defined.
Hey, no, I listen. I'm a pragmatist. Whatever results in a great design, and it's your process that you own. You know what I mean?
Exactly. Yeah, I mean, if it works, that's what matters.
I mean, hey, listen. When it comes to my day job, the fucking chairs, like you ask me, any of the key dimensions of any chairs that I do, fucking rattle them off. Like, the length, width, material efficiency of a part, I'm in manufacturing. Like, I deal with all this stuff, that's like my day job. When I design guns, it's like, oh, I want to let loose and do cool edgy CAD, not the boring stuffy. So I mean, like,
Okay. My CAD is both stuffy and boring.
No, it's not though. But like, it's like, so I have a really long desk right here, and over here is my workstation.
He literally has two different desks, and he transitions from personal.
No, it's one desk. It's one desk.
Okay, 2 different desks in one, and you can slide back and forth. It's the strangest thing if you guys have ever seen it. I don't know. It's just weird.
So I'm at work, and I'm doing boring stuffy CAD. 5 o'clock rolls around, I slide over here, crack a beer, and start doing cool edgy CAD.
That is actually, I actually really, that idea very much appeals to me. I like, I don't know, I do like that idea.
Unbutton my shirt, start doing the cool CAD.
Yes. Okay. So, and yeah, I do have one question. We'll just before we leave, I'll ask you about your shirt. I do have a shirt question for you, but this is another example of surfacing. So this support rib, this is the new support rib, which is the most perfect support rib I've been able to come up with to date. And I'm actually not happy with a part of it, but what I wanted in a support rib, my previous support rib on all my older lowers I've released was simply a lofted surface. I mean, not a loft, it was a lofted body. It was just a loft that was defined by a bunch of curves. And it was just kind of if you ever looked at one, it's just kind of a sweep. It's not very efficient. In order to prevent it from interfering with so the problem is, if we look along right here, this profile, there's a profile right here. That profile is designed to fit upper receivers. That's the purpose of it. Upper receivers are straight and parallel along that surface for the most part. There are some features, but in general, we want this surface. I'm not matching a particular part.
It just can't interfere with 90% of upper receivers.
I want this surface optimally for what I'm doing. I want this surface to extrude directly perpendicular to the buffer tower. I want this to be flat, straight out
to the buffer tower. Yeah. Okay. Got it.
Yeah. Exactly. The plane that would be right here. Obviously, that's open right now. That's what I would want. So I finally achieved that with this support rib. And I also, the older one had like not a properly defined radius on the top of the rib. So this one here, I have a nice properly defined radius. And then what I'm not happy with is just because the very nature of what I'm trying to do, I end up kind of with this little bit of a bend right at the end here. That's just geometrically, it has to be that way, the way the parts fit together. And it kind of gives you this Roman nose look up front, which is like, I don't know. I'm not a giant fan of that, but
Roman nose.
It's a sheep term. I don't know.
Ah, okay. I thought you were into what's the pseudoscience of like head shapes, like for phrenology.
Oh no, that's separate. That's separate. Yeah, we can talk about that next stream. But yeah, it just kind of has that little lump there I'm not super happy with. But just to back this up and show people kind of why you really have to have surfacing to do this properly. And the way I did this, it all started with a plane. This is the important surface. This is the number one thing I have to define. This is a extruded straight, it's a surface extrude. So it's a surface that's just an extrusion. It's just a perfectly straight surface coming off of one line, one sketch. And this is the inside, and it's totally straight, as you can see. And this is the part that is going to be on the inside of the support rib. It's going to mate with the upper receiver. That is a critical part. So that's why I draw that. That's the very first thing. And then I use split lines and delete face like a lot. That's like my primary tool right now. So I've used I draw a sketch right here on the center plane. I then project that onto onto the surface to split it like that. And then I use the delete face to delete it. So that's kind of my current toolbox. That's like the number one thing I use for I just trim surfaces back to get them where I want.
Yeah, I mean, I use that type of stuff a lot. I mean, in a slightly different way because, I generally am like working just with the solids. But I definitely, I mean, curves is something that, that was a revelation for me in the past few years, working more with curves.
Curves like splines or
Well, like sketches projected onto surfaces.
oh yeah. I see what you mean. Yeah. So no, okay. So as far as that goes, I see what you're saying now. Curves, I try to avoid them where possible because they tend to be unpleasant to work with in SolidWorks. Like you can't relate everything to them. So what I like to do instead is I just use the split line to split this face into
Yeah,
two different pieces.
you're using a curved surface to split another surface and then deleting half of it.
Yeah, or even if I don't delete it, I now have this edge right here to work with, and this edge is very robust and easy to work with. So that this is kind of the, if I wanted to get like and that's basically equivalent to a 3-dimensional sketch now. So you can obviously that
This is what we meant earlier about 3D sketches being stupid. Like you should define them using other features.
Yep. Where possible.
Yeah. Well, it's always possible.
Well, I could give you. I'll show you where I use a 3D sketch just because
if you can show me one good use of a 3D sketch, I'll eat my fucking Shiba.
Okay, I'll show you where I used one, and we'll judge whether or not it was useful. And no, we will not be allowing any eating of the world's cutest cartoon dog. Okay, so in this particular case, I deleted that because I don't care about it. So I now have that's the inside of my support rib. That's what I want. I've cut it to where I want it. Everything's nice. Everything's perfect. And then I add a rule. This is a weird little thing I did here. I basically added a ruled surface.
Yeah, it's basically a swept surface.
Yeah, but it has the great feature that I can make it perpendicular to the surface it's ruled off of.
Yeah,
so
it's in solid edge, swept surfaces are by default perpendicular to the surface they're coming off of.
Ah, okay. So this is kind of the equivalent of that then.
Yeah.
I think I could maybe this is just the easiest, simplest way to do this in SolidWorks. And then I use another split to split that, and then I delete it.
Yeah, just to trim it up.
Yeah, and that's to make it so it's tapered now because I wanted it to taper.
We use surfacing in wildly different ways. So like, have you ever seen someone who's really good at Rhino do like a Rhino workflow?
I haven't looked into Rhino hardly at all. I looked into a little bit enough.
Dude, oh shit. Your workflow here is like Rhino workflow fucking 101. Like this is how people make like
I feel like that's a bad thing. Like it's
not a bad thing or a good thing. I'm just saying like this is really reminiscent of basically how people construct like complicated shapes in Rhino. Is basically making like a whole mess of surfaces, stitching them, and then making them watertight.
Interesting. This is not like my normal workflow. Like, I mean, the Orca would be like, I don't really have a normal workflow. Like, it's constantly changing. So this is what I've settled on in the last week. I just started this like 2 days ago. So this is what I'm doing.
I hesitate to recommend Rhino to anyone, but if you're getting really into like this type of work, well, you're not going to get the same like parametrics, but like,
well, that's the thing. I've looked into Rhino a little bit, and from what I can tell, like I have not been impressed. So like, how could you do this? And then how could you do surfacing without parametrics?
No, you mean you have parametrics. It's just not like, it's not as organized.
I see.
But like this is like how Rhino wizards work. Like you're basically doing the So you're basically doing the Rhino workflow, which is very interesting to see. I've actually never seen someone like do a workflow like this in like solid modeling. Like
that's weird. Okay.
Well, it's not weird. My work, like the workflow that I'm doing with like V3, where it's you start with a solid and refine it, is much more typical of like high level solid modeling work. This is like I'm not saying what you're doing is bad. I'm just saying it's an interesting use.
That makes, I mean, I understand that, but like refining a solid model is something that nowadays I would probably use that for more of a mock-up. Like that's what I did for the initial design on this. I was just cutting away from like, I did a basic solid model for like the main body here and then like the grip, and I kind of cut away at it to get an idea of what I wanted to do. But once I did a few iterations of that, I had a solid idea of what I wanted to do. And then I'm now using just surfaces to really make a robust model where everything integrates super nicely. That's kind of the idea I have here. As I said, this is actually the first time I've done this, so we will see how it turns out.
I I think that once you get to this being feature complete, you're not gonna like this workflow anymore.
Feature complete, as in
like having all of the features complete on it. Like
okay,
I think once you
no,
take this to the end
okay,
stage.
yeah. So okay, so my full intention here, the way this
No,
is
no, no.
this is gonna work.
You're gonna convert it to a solid at a
Oh
certain
yeah,
point and then
yes,
build on
exactly.
top of it. I know you're not going to do the entire thing in surfacing. I think once you've taken it to that entire place, though, I mean, if I'm wrong, I'll give this a try for my next frame. Like, if you take this all the way and still think how you're doing it right now is like how to do it, I'll give it a shot for my next frame. But I think once you try to go back and like fix mistakes you've made once you've built features on top of this, because everyone makes mistakes.
Yep.
You have you know you can't see it yet. I can't see it yet.
Oh no, they'll be there.
You have a mistake already somewhere in this foundation.
Probably in here somewhere. Yeah. So I see what you're saying. It's gonna be hard to go back and fix it, but the way I normally do things, it probably wouldn't be any easier to fix. You see what I mean? So the way you're doing it would make it easy. So your method would be easier to fix, I think.
Yeah, my method's super plastic. Like I lose a lot of clarity, which would drive you crazy. Like once I get deep into my feature tree.
That your feature tree does drive me crazy.
But my foundational feature tree is as good as yours. Like I build on a strong foundation and then I like revise out from there. But like my foundational features, my grip angle, my backstrap, my front strap, my like base thumb support, and all of the mechanical stuff is defined extremely early in the feature tree and either locked down or other features are added on top of it in a way to keep those features editable.
Yeah, I mean that having a solid foundation is what's so critical, and having all your basic everything, all your basic stuff nailed down. That's what's important. If you have something fundamentally wrong, the model is going to be very hard to work with. But once you have that done, you're off to a much better start.
I mean, man, you're kind of in the great unknown for this as far as I'm concerned. Like you're doing solid modeling like it's Rhino.
Huh, I'm not, I guess I need to look into Rhino some more. That's interesting.
Yeah, I mean this is Rhino. Like if you stripped out like the if you just screenshotted your like viewport
without all the tools.
Yeah, I'd say like, and you said like, hey, what CAD program is this? I'd just immediately say Rhino.
Huh, that's funny. I wouldn't have. I will look. I did not realize Rhino. I always thought of Rhino as being a little more meshy type based.
No, Rhino is fully developed. So Rhino, I always call it the Swiss Army CAD because you can do literally anything in Rhino. It's just never the best tool for the job.
I don't know. That doesn't sound very good. But
Rhino has a place. I keep Rhino on all of my computers.
I see what people do with Rhino, and that's kind of what makes me so skeptical of it. Like I see people doing very organic, non-precision things, models and stuff. Like I see them doing very artistic, animated object type models and stuff like that. That's just what I've seen. Like I haven't really looked into it in detail though to know everything.
Yeah, you got to spend some time with some real fucking Rhino wizards because like Rhino has this really popular add-on called like Grasshopper that makes like organic like stuff like vases and shit super easy to do. And so you see a lot of like low skill Rhino stuff just like using Grasshopper to fucking churn out vase number 53 and pot number 15.
Not anything really not really anything that could be not anything that's designed from the ground up.
But I mean there are like high level Rhino wizards out there. There are people who can really make Rhino sing for solid modeling. Like
But I mean, this is going to be once this shell is complete,
it becomes a solid. Yeah,
and I'm going to be doing a lot of solid modeling on top of it. There's lots and lots of features that
I know,
are going to have
but
to be added.
it's the workflow that I'm actually just skeptical of. I hope this works I hope this works, and I'll be really interested to see it once you have it working. But my impression is that you're basically fighting the software.
So right now, I mean, designing this, now that I kind of understand how I wanted to use my features, this has been very pleasant to put together. Like, I haven't had any issues. It really has been very smooth. However, when I first started this a week ago, I didn't know how I wanted to do any of the features down here, for an example, by the grip. Like, obviously I'm adding this, this curve inside of here, and this piece right here, the way this is modeled, I had this as like an extrusion sideways and such. So once I figured out how I wanted to do it, all the pieces have kind of fallen together, and this has actually been very easy to do. Like, being surfaces over a solid hasn't really made a huge difference, because if this was a solid like it was on a previous model, both the magazine well right here and the main body, as I call it right here, those are both solids. But as I added features like the area, like this feature right here, this surface, I ended up just cutting those solids apart into surface, as I'd remove those faces and then add the curved surface that I wanted. So it's not really any different.
No, I mean, don't get me wrong. I see your logic here, and the model looks really good. I'll just be curious how it
ends up in a month.
Yeah, how this actually how this merges with like the stuff that you need to do in solids, and what.
Well, we're gonna find out. We will see.
Yeah, I'm gonna keep asking you about this, because I'm super curious how this actually like plays out in the end.
Yeah, we will see. I don't know. Right. Far,
it's not because there's anything wrong with this workflow. Like I said, like I've seen people do workflows like this who are some of the best CAD people I know, but I've never seen someone do a workflow like this in Solid Edge or SolidWorks. Like, this is a workflow that I see most closely associated with Rhino, and like the really good Rhino people that I've met who've worked like this basically take something like this and then convert it over to SolidWorks normally to like, make it production ready. I've never seen, and maybe this is just like, maybe it'll work really well, and like you might just be, it's much easier to do this type of workflow in Rhino. So I think
what in Rhino would make this easier, though? I mean, because
it's built around this type of workflow.
That's okay. Well, I will have to look into Rhino in that case.
No, you shouldn't, because you're doing.
I'm curious now. I'm curious, like how their workflow would be more optimized.
I mean,
doing parametric surfaces.
There's a difference between like doing parametric surfaces. Like, I consider myself as a guy who like does parametric surfaces. Like,
well, you do. I mean,
but
just don't dimension them.
Well, but it's not about the dimensioning them. It's like how I'm using them. I'm using them in the context of a solid modeler. Like, I'm using parametric surfaces to modify solid.
A solid, yes. So rather than what I'm doing, and so I've done that in the past, and I still do that in some parts. It seems cleaner to me simply to build the solid from surfaces rather than just cut it and modify it at an early stage. Later on, when I want to add a particular feature,
but you're putting refined features into this point. Like, you're rounding stuff over that just like should be like fillets. Like,
so to you, well, I mean, some stuff here is actually
like
like this. That's a fillet. That's a fillet right there.
Yeah, but why would you put that into this stage where it basically becomes uneditable? Because you want it to merge into that.
This fillet merges into all of this.
But you can always do a variable. So you can always.
No, I know. So I have used variable fillets.
No. But why don't?
I don't. So avoiding the use of fillets is actually like a big thing I'm trying to do here. I don't know. I hate fillets. Fillets are my number one enemy.
I hate them too.
Variable fillets are the worst. And I'm going to have to use some. There's going to be like this. This is going to be a fillet at a later stage here. All of this underneath the support rib is going to be all one big variable fillet. Because that's the best way. I mean, it would be silly for me to try to surface model that curve. It would just be like unneeded work.
Hey, this is just for chat. This isn't an argument. Like, we're not arguing about like how people like two grandmasters don't argue about how to play chess.
we're just discussing the different options here.
Like at the end of the day, no matter how Hoffman does this, he's gonna end up with like an S tier AR model. I'm confused because I haven't seen this before. I haven't seen someone do something like this in a solid modeling program to this extent. And
this is totally experimental. When I started this, I was like, I basically just asked myself the question, why am I making this a solid if I'm just going to cut it open later and patch it back together? I said, why am I even doing that? It just seems cleaner to just start with surfaces and then at the end of the day, patch it together and then turn it into a solid and boom, there's my complete body. And I can start adding my refined small features. Like I know to you probably are thinking that some of these curves are refined, but to me, like this fillet right here, this is a gross feature.
That was the meanest thing you've ever said to me, you son of a bitch.
Which one of the words was it?
To you.
I see. Okay.
No. Here, like
I see. Okay.
My concern here is that once you take this model out of like the conceptual stage, or like the early foundational stages.
Okay, so what you're not seeing here is you're not seeing my like 6 other models I've already done of this in the conceptual stages. That's the I don't go through my workflow is not in one. I'll do one lower until I get to a certain point just to understand how I want to do it, and then I'll start again in a different order of operations, and that's what this is. So I've actually started from scratch on this guy, just basically taking sketches over from the other model where needed to save time.
Let me be very clear. I don't think at the end of the day you won't be successful doing this. Like I think you're gonna make a really good model. What I think is gonna happen though is you're gonna get to the end of this and say,
I wish I solided it.
Or I think you're just gonna be like, yeah, that worked, but I'm not doing that again.
Well, like, we're gonna see. We're gonna see. We will see. Okay. I don't know. The idea of mixing solids and surfaces in the same model just doesn't appeal to me on a base level. Like I did it, but if I can do it all surfaces without wasting a ton of time, which I haven't, it's actually gone together really quickly.
You're like, I mean, I'm the same way, but like you have an idea and you get fixed. You're
no, it bothers me. I don't know. I want it to be neat, like symmetrical, just not a mess. I don't want like a tangle of stuff here. And we have 3D arms in the house. He says, next, let's do boxing streams.
Oh, Tim would beat me, man. He'd kick my ass.
I don't know.
I'm old and I drink too much. This guy is fucking young and only drinks the finest milk and cream. He'd beat my ass.
Exactly. The latter part is true. The milk and cream part, absolutely the finest. Okay, so
next time I drive home to DC, I'm stopping at your farm and I'm drinking some fucking milk.
You need to, seriously. Yes. Anytime, just let me know when.
I used to volunteer for the Farm to Consumer Legal Defense Fund, which was a law group that specialized in defending farmers who were like selling raw milk to people because it was against the law. I used to very much,
that's a big problem.
I'm a raw milk. You know that book? It gets shared as the cover gets shared as a meme. Everything I want to do is illegal.
Yes.
That's Joel Saladin. He's a farmer in southern Pennsylvania.
Oh yeah, I know who the Joel Saladin is. Yeah.
Yeah, I family friend.
Oh, really?
Yeah, no, we've
Seriously?
been to his farm a bunch of times. I fucking banged one of my girlfriends in his barn once.
That is pretty funny stuff. That's funny, you know.
Yeah,
Yeah,
dude.
yeah. He's been basically the guy for a long time. Still
Yeah,
around.
well, yeah. I mean, the Farm to Consumer Legal Defense Fund, the Sally Fallon Foundation, like, I'm big on raw good milk.
Oh, that's excellent. Yeah, I guess. I mean, you did mention we talked about this a little bit, so this is always a good thing. Yes, as Simon says. Yes, based milkman,
Well,
absolutely.
based Hoffman, he's the milkman these days.
Yeah,
I live in the big city. I can't get good milk to save my life, but
it's true. It's true, and that's the as we discussed, major disadvantage of metro urban areas.
yeah, I mean, that's the problem with city living.
Yes. Yeah. So back to the model. The basically I just did the support ribbon stages using surfacing. So we had the inside, and then I did the top edge right here. And the top edge, I did something weird. I wanted this to like twist in a certain way. So I did that ruled surface I talked about earlier, and then we tapered it as I wanted, like that, to kind of get the taper. And then I added this secondary boundary surface right here. And this is just another, because this is adding, this is adding an offset and a little bit of a twist. So basically I'm trying to define, and then I added a curve on top of it, and then I just deleted that geometry underneath. That was just
okay, I get it. Yeah, it's just
that's just reference. But that basically I can now tweak how this top twists and how it sits on top of my primary inside surface. And now I have this nice radius surface on top, this nice properly defined tapered. It gets narrower at the top and then gets wide at the bottom to properly interface down here with the rest when I lower, which I have not drawn yet.
Here's my fucking problem with you, Tim. Here's my problem with what you're doing, and here's why I think it's fucked.
Okay.
You're focusing on, the surface solid dichotomy and not on the more pragmatic, like bigger feature to smaller feature. So you have small features in here. You have small radiuses.
No, so that's cool. You're seeing them as features. When I look at this design, I'm looking at these basically as like as almost as like an assembly. So when I look at this, I see 6 different components here. Basically, there is the magazine well right here. That's one component. I then have the lower body. It's this guy right here. I then have the grip body. It's this guy right here. Then I have the support rib, which I'm designing right now. Well, before that, I have the buffer tower. Then I have the support rib. And then I have the right side reinforcement, which is the reinforcement over here. And that kind of idea of putting together those 6 different features came from my earlier designs. And that's just kind of how I've thought about lower receivers ever since. So that's kind of how I think about lowers. And that's how I'm designing this. I'm designing this in a pretty orderly way. I design this guy, and then I design the main body. Then I design the grip. Then I put the buffer tower in there. Right now I'm doing the support rib. And each of those features, when I design it in completion. I'm fully surfacing it. It's now done. And then I will, then I tie everything together as needed. Like obviously I have this joint right here. I have the grip tied into everything ties together, but that's how I'm thinking about it. When I'm doing this, I'm not just like focusing on this little curve here. I'm focusing on the support rib. That's what I'm designing right here.
No. I totally get that, but like
they aren't small features. I mean, these are all major base level features I'm putting in.
The radius at the top of the support rib is a base feature.
Yeah, you can't put this radius. You can't put this in later. This radius is absolutely critical to the support rib properly integrating into the rest of the lower. I can't like just leave that, like put a big clunky guy in there and then try to radius it out later. That's not gonna end up being properly smoothly integrated.
All right, Hoffman, Tim, I think you're gonna regret going this way, and let's make a bet.
Okay, let's do this.
Let's make a bet.
Okay.
I will find you a fucking bottle of hydrogen. I will find you a bottle of liquid hydrogen and have it delivered to your farm.
I don't think that's. You might as well offer me a nuclear weapon. I think.
You can't find like a liter of liquid hydrogen?
No. I mean, this is more challenging than you think. Work on those infiltration, those facility infiltration skills, because you're going to have to break in to get it.
Hot air balloon ride. I will pay for a hot air balloon ride for the two of us.
That's more like it.
All right. I will pay for a hot air balloon ride for the two of us. If you get to the end of this project and say this was the right way to do it. If you get to the end of it and say, yeah, I think Chairman was right.
I will then pay for the hot air balloon ride.
No. You have to overnight me some of your finest milk and cream in a fucking, ice box. So it's fresh when it gets to me in San Antonio.
Okay. Yeah, we could do that. I think that's fair.
And either way I win, I either get a hot air balloon ride with Hoffman or I get Hoffman's fresh cream.
Yeah, okay. I think we'll go with that. I think we'll go with that. I don't know. I'm confident I'm going to like this, but
well, I've set up a bet where I win either way.
Well, I mean, okay. I see it as okay. You could definitely look at it that way. I mean, I would agree. A hot air balloon ride is always a win, so that's good. All right,
you've never been in a hot air balloon.
I haven't. No, shockingly, I've actually got a bunch of books. I have a bunch of balloon specific books coming in actually on this subject.
Well, I know you don't like hot air balloons on principle, but they are balloons and you can fly on them.
Hot air balloons are still lighter than air, and they're still in the greater lighter than air family, and they still deserve our respect and admiration. So absolutely, yes. And we have Middleton made in the stream, and yes, we are surfacing. That is what we are discussing today. Okay, yes, we'll take you up on that. It's official. Everybody here on the stream, we have, I think, like 55 people on YouTube and 32 on Odyssey. So yeah, absolutely. We will probably do another CAD stream when I finish this up then, and we will talk about it then, if that sounds reasonable. Has Chairman frozen? I think Chairman's frozen. Yep, I think he's frozen. Yep, we have lost Chairman. He is now frozen. He's dropped out. He's probably trying to fix it. Okay, so it is getting 47 minutes past when I was planning on ending, but we're almost done here. I just wanted to finish showing you guys the support rib idea here. So I'm not sure where Chairman went. We'll see when he comes back. Okay. Okay, yes. Neko Ivan says CAD streams are so underrated. I'm glad you're enjoying it. And this is, I know, taking a long time, but that's how these streams normally go. It's kind of a back and forth. I hope you guys are learning something here as we go and discuss different esoteric things. There he is. There he's back. There you are. We lost you for a little bit.
I don't know what happened. I completely lost internet for like 30 seconds there.
Oh, wow. Yeah, you just froze up and then disappeared. So we were thinking, I don't know, rated or something.
No, just which is weird because I have like excellent Google Fiber, and that usually never happens.
Does he look different, guys? Is he wearing different glasses, or no? He looks the same. No, looks the same. All right, just making sure like there wasn't a sudden, Hergé style swap in the background. Different professor. Okay. So
hey, comrade, what are these armaments that we are seeing on the screen?
Yeah, so armaments. We're actually designing, this is architecture. This is a new building. It's going in Dubai, and swimming pool goes in here. Yeah, we're just kind of laying it out. Nothing too exciting.
Looks like American M15 fully automatic semi-rifle.
Very good. Very good. Very good. So the last part that I really I still haven't totally figured out, and this works, but I'm not totally happy with it. I'm trying to integrate this rib into the what I'm going to have down here eventually. And the way I'm doing that is I'm just using my favorite little split line and then delete face to eliminate part of this radius right here, or that top. It's not really a radius. It's a complex curve, but to eliminate a piece of it. And then I put a boundary surface to kind of resurface that down to this curve right here. This is kind of this is the terminus. This is where I want the support rib to terminate into this curve. This is where it terminates.
Can you zoom out a little bit? That actually. Oh.
You see, that's where the support was going to terminate, and then I have another surface that kind of extends forward into the magazine well, and then on this side over here, I have the same surface that then transitions into my right side reinforcement. So it's all symmetrical up front, and then it goes to a rib, and then different reinforcement on this side, which I don't have drawn yet. But I kind of use this surface to bring me down to that curve, and then I can't. This edge right here is not tangent. And I end up being at a sharp corner down here. So I just use a split tool to split that guy and then delete. And then I use the surface fill tool to fill him back in and add like a nice little radius there. And that actually really blends. I'm super, super happy with how this came out, because this edge right here, this edge right there is not a radius edge. That edge is not tangent to the inside surface of the lower. It's a sharp edge, because we want to have the rib as close as possible to our upper receiver for maximum strength, and adding a fillet or any kind of radius or tangent surface there is simply going to be making us have to move the support rib further out, making it thinner, and that's no reason for that. So this is going to wrap around here. There's going to be a sharp edge here, and then it's going to transition into a curve down here later on. But that's a minor feature we don't add now. We add that much later. So that is what I do there. And then the last and most tricky step is we add a surface. I'm basically just using this surface to create a 3D sketch. Obviously, we've talked about this. So I put this surface here, and then I just split that surface right there, and I'm generating a line that's obviously three-dimensional. Look at the end there. And that is, I'm doing this instead of trying to use a 3D sketch. So this is like, rather than using 3D sketches, this is like the right way to do it.
Never use 3D sketches, guys. Hoffman and I are in 100%. Well, he says that there is a use case, but
yeah, I did use one. Let's see, where is
but
that?
Not 99% of the time do not use.
Seriously, I may not. I seriously might have actually gotten rid of it earlier and gone to a better method. Seriously, I'm looking. I don't see a 3D sketch. This is funny stuff.
Yeah, don't use 3D.
Oh no. There is one there. I will show you it. Okay, I do have a 3D sketch buried in there. I will show you. So yeah, I agree. Seriously, guys, 3D sketches are not good. Like they are bad. That the 3D sketches legitimately, there are better ways of doing it. I will show you where I use the 3D sketch, and we'll just quickly talk about why. So this entire plane is just here for reference geometry, just to get that line. So we get rid of it later. I then add the outside surface, which is based off of a bunch of different curves. You can see we've got a bunch of curves in there right here, just trying to define the curve. This surface goes all the way down into the middle onto the inside. It's basically that entire side is the outside surface. And this is the hardest part to get like right. The place I used a 3D sketch was right here. So this is a 2D sketch drawn on a plane. And this just kind of, okay, I got to back up just 1 second here. So I have this split line. Let's just come up. Let's come up there. Let's just back this up, make everything visible. Just a second. There we go. So this line right here, this line right there is the junction between where I want my support rib to meet my lower receiver. That's kind of the cutoff line. So this is one of the lines that is part of that surface. It's
that makes complete sense.
Yeah, right. I mean, obviously, because if you don't do this, then you don't have an even line where the two surfaces meet. It just looks stupid.
You have to define where these surfaces come together.
Yes, exactly. And the surfaces don't end there. The surface that the support rib surface goes all the way down to this line down here. Because for various reasons, we don't want to go into that in too much detail. But basically, I have this surface, this line here. I want this line to be part of this line right here. This basically is all one big guide curve right here. And if you look at it carefully, you will see it is indeed three-dimensional. So the only reason I use the 3D sketch here is I used a split line to generate this edge. So I have these edges right here I can use. I just split out to this surface. These surfaces are curved. That's a curved surface.
Tim, I
Yeah.
I don't see any dimensions on that 3D sketch.
No, so just a second. We're getting no. We're getting there. This sketch right here has dimensions. This is a 2D sketch.
Fuck.
The purpose of this sketch is it just connects that line right there over to our buffer tower, and it's sitting at a weird angle.
I was hoping you slipped up.
No, not here. Not here. It's sitting on a plane right there, so that's all perfect, right? But the problem is, I need to take this 3D sketch right there. I need to take that 2D sketch right there and connect it into this line right here.
Yeah, that's tricky.
Yeah, so the way I do that is with a 3D sketch. I take a 3D sketch, boom, you'll notice there's no dimensions on that, right? So this is a 3D sketch right here. And this is the only time I would use a 3D sketch. I'm just pulling sketch elements from other sketches and other features and just dropping them in here. So obviously that right there is just using a transfer tool.
That's fair. You're just you're combining some 2D stuff into it.
I'm combining several different sketches together in the 3D sketch, and this is the best way to do it.
So Tim, shockingly, that we do have a few people still watching.
I know, this is ridiculous. We actually have almost 50.
I think 49. Middleton's about to leave, but
yeah, and I'm about to leave too. Actually, we're almost
I know we're right at the end, so I just want to touch on some just really basic stuff. How would you recommend someone learn to 3D model in like program aside? How would you recommend someone kind of pick this up from scratch? Because there's people who are just watching this because we're fun dudes,
Yeah, that's a good question. And I would say if you want to learn a 3D model, you need to have something that you want to design first. You have to have something you want to design. Just copying stuff, you need to have something that you have a goal, a purpose, the reason you want to design it. It needs to do something. You have to have an idea in your head of what you want to design, what it needs to do. That is your starting point. And then from there, you need to just, even outside of CAD, you need to develop what that part is going to look like. Like just CAD is just a place for taking an idea you have and then turning it into an actual shape that you can use in a computer to 3D print stuff or whatever. You actually have to have the idea to begin with. You have to have something you want to do. So obviously that would be the first step. Think about something you want to do, and then just jump into the CAD program and start using basic tools to try to draw it.
So I disagree fully with Hoffman there, but that's okay.
Okay. All right. That's what I did. So
I think that the best way to learn to do CAD is to just grab an object. Doesn't matter what it is.
This is so boring. You will get burned out so quickly doing this.
It's the best way to learn because you can check your work. Grab an object, and this is easy if you have a 3D printer because you can just print it out and check it against what you're trying to model. Grab an object, grab a pair of calipers, and start figuring out how to translate that object into your CAD program. If you're trying to learn from scratch, you don't know any CAD. Like you're literally just starting to get into this. Modeling an object that you grab from your environment, I think, is the best way to just learn the basics. And
okay, that's a fair point.
You get to the point where you design in CAD. So do you sketch? I'm curious. Do you make sketches?
I do actually. I'm not going to show anybody any of them because they're kind of scary. But yeah, I do actually. I have a notebook, obviously, so ideas go in the notebook to begin with to try to record them, what I want to do. That's super basic. That's like no geometry, just like basic concepts. And then I'll do most of my working out my geometry in CAD, but I always have a piece of paper on hand just to draw. Like I'm trying to work out with the way I want to lay my surfaces out, like around my trigger guard down here. I'll definitely sketch different ideas up for that before I try it. So yeah, I find that very useful because it's a lot faster. And it's just really fast to help me visualize stuff. So yeah, I do that to some degree, but not like
we're just like completely wildly different. Like I never sketch on paper. I just open CAD. I'll open CAD without an idea, and I'll just like start modeling. You know.
Oh my! I mean, I understand that CAD is an incredible tool for helping you visualize and understand what you want to do. I mean, I do that to some degree too, but I'll always do a little bit of sketching just to try to solidify my idea, unless it's something simple.
I mean, this is why I always like I always enjoy doing a stream or a conversation with you, because like we couldn't be more different people, but like we're into the exact same thing and like have the same passion for it. And
yeah, it is funny how different the way we do things is.
Well, you know, I mean, talking to someone who is just doing stuff exactly the way you do it, I mean, that's incredibly boring. What's there to learn?
Very little, and it is very boring. Yeah, that's why it's so interesting. Yeah, I mean, just the way you do things is so different. Like I look at it like, wow, like I've never even tried a lot of these techniques before.
Yeah, I mean,
most of them actually.
I mean, like, you know, I'm getting ideas looking at how you're doing this, and I mean, I never would have considered doing this in a solid modeling program. But I can see the advantages of what you're trying to do here. Like,
I mean, it's not the program is very fluent in both solid and surfaces.
Sure, so, of course. It's just I've never seen someone do this in a solid modeler, because, you know, it's always what I've always assumed is like there's no point in doing that in a solid modeler, because it's a solid modeler. You can just start with a solid and refine it. But you're clearly getting good results here, so I wouldn't have even thought to approach it this way. I mean, I'm very interested. I might wait for you to get a little further along in this model and report back before I try it myself. But it's really an interesting way to do things. I mean, I'm fascinated by how you're doing this.
I know I said so this is kind of new to me as well, because I just started this. I've been doing this basically like the last week. This is all I've been doing. Like I need to be doing a video, but I've just been kind of obsessing over this lower, trying to get it where I want it to be. And this method is kind of what I've come to, and I'm just trying to bring up show. Let's see.
I mean, the results speak for themselves. I mean, Shockburn just left a great comment. There's no wrong way to use CAD if the final product is what you dreamt and it works.
That's what's so interesting about CAD is you can use it in so many different ways, with so many different results. I mean, you can do the same. You can get the same result with many different tools and methods.
Yeah, I mean, like, you know, it's CAD. Like Tim loves some of my models, but when he sees my feature tree, he literally gets anxiety. Like he can't.
Wow, he's not kidding. His feature tree is really scary. Yeah, no, it's really scary. Yeah, so that kind of sums up all the surfacing type techniques that I'm using right now. I mean, it's not super complicated. Really, you just, if you're going to use surfacing, you need to have a good reason to use it. Obviously, on the stuff that Chairman's doing, and like with the support rib and the pistol grip here, and even, you know, these features right here around the trigger guard, these are all great reasons to use surfacing. Obviously, I'm surfacing everything here, like as we've been discussing. That's not, this is there. If you were just going to design this magazine well, surfacing would not make sense. You're wasting your time, because you could do it way faster with just the one quick extrusion feature and then a quick cut. So you have to have a good reason to use surfacing to do it. But if you're looking to do more complex curves or more complex geometry, it will make your life much easier. So I would definitely
most normal people use surfacing more like I do, where you're combining solids and surfacing from the get-go. I'm really into what Tim's doing here, but don't be put off from trying out surfacing and think that you have to do a fully surfaced model.
Yeah, that's what I'm saying. No, you don't have to. You can use surfacing to make, like, for an example, what I did in my earlier designs is this entire thing was solid modeling. The only surfacing I did was just for the support rib. This was all solid, and I just surfaced the support rib. And then after the support rib was surfaced, I just basically attached it to the rest of the solid model.
Yeah, hey, Tim, that's not a criticism. I'm just I don't want the folks at home to get scared from trying
Listen,
surfacing
I think
thinking
the
that they need to.
insinuations here are that this method is more difficult.
That's not an insinuation. My gut feeling is that you're a crazy person.
Okay.
But
Okay. All right. We see where this is going. So yeah, you do not have to do a ridiculous amount of surfacing and all kinds of this complex stitching stuff together in order to use surfacing to excellent effect. Anywhere you want to have some sort of nice curved part, which you're kind of struggling to do with extrusions and fillets.
If you're designing a handgun, if you're doing a Glock frame, you're doing an M&P, you're doing a 1911. If you're not using surfacing for your core ergonomic features, you're leaving a lot of good stuff on the table. You know, if you've spent 10, 20 hours on this model and haven't used surfacing, that's like, I mean, just think about, you know, don't spend that much time doing something and do a substandard job. Learn these tools, get familiar with them. You don't have to use them to the extent that Tim is. I mean, Tim is showing off extreme surfacing. And that's not a criticism. That's
I don't know. It's not that scary, guys. This really isn't. I mean, this entire feature tree here has like I have like it's not big. My feature tree is tiny. All this like scary surfacing, I have this little tiny surface tree. I don't know. I have like 100 sketches. I'm at like, if I do a sketch right now, I think I'm at let me we actually get let's see what this is. I'm at 105. I have 105 sketches in this model.
That's not
in Chairman's world. That's tiny.
That's not tiny. A lot.
This is little. Now it'll be a lot bigger when it's done, obviously, but because this is just the basic part, but that's not a lot. This is easy. I just did this. I started this model from scratch without any features in it, just a blank document. I started this last night and I worked until about 11 last night. So I've been working on this maybe for like 9 hours now. That's it. And we've got to this point. So it's really not that bad. It's really not that bad. Yeah. So to close things up, what I'm going to do is I'm going to hop over to the, just a second. I'm going to hop over to the Odyssey chat. We're going to run through there and then we're going to close out for the night. Pop out chat. Yeah. So it's just surfacing is actually, as long as you have a good application for it, it's much simpler than, there we go. Surfacing it, it's really not, it's just defining it with curves. Like, I mean, you saw what you're doing today. It's really not that.
It's much easier to make complex features like this magwell, this, this grip, this type of stuff. You can use surfacing any way you want. You can use it to fully define a part like Tim is doing here. You can use it to modify a more primitive part like how I tend to use it. And you can do anything in between. I mean, it's not an end in and of itself. It's a tool.
It's great for references. Like, I mean, I use it, you use it. I'm using surfaces as reference geometry for something else. It has a lot. Once you start understanding once you start using it, it has a lot of use cases to make your life a lot easier.
I mean, I think we can both agree that if you're spending significant time in CAD and you're not making heavy use of surfacing, I mean, sure, if you're doing like milling and like machine parts and just simple stuff.
If you're doing basic, not 3D. If you're doing 3D printing, you really should be using surfacing because you can make what you're designing better without any compromise to the end user trying to print it. If you're trying to design,
if you're doing 3D printed guns, you really should be using surfacing to just make what you're designing better.
Yeah. Just start experimenting. Especially if you're using something like SolidWorks or I mean, no one out there uses Solid Edge. I don't think at this point. There's probably very, very few.
It's niche. Hey, Vega Holdings, the Aeron chair is better in my opinion, but the Embody chair, I mean, you can't go wrong with it. I just think that for the sit, you're going to overpay for the Embody when the Aeron is cheaper on the used market. There's a lot more used Aeron chairs out there, and it's just as good a sit. I mean, I sit in an Aeron that acquired used. But hey, if you're buying new, I think they're equal.
Esoteric chair talk. I'm not sure what you're discussing, but
we're talking about high-end desk chairs.
Ah, okay, interesting. So we have a good question here. So I'm just going to go through. We only have like just a few of them over here, a handful over in Odyssey. We have what is the from Bigfoot Goes Boom. What is the advantage of Solid Edge over SolidWorks? So if you just want to quickly expand, we've talked about this in the past, but just the quick difference.
It's free.
Yep,
and
that's a big one.
The biggest one for me is I think the part assembly relationship dynamic is a lot more user-friendly, intuitive. It's a lot easier to work on a part in the context of the assembly and reference those small, reference details from other things using Solid Edge. But from the capabilities side, I don't think there's a difference at all. I mean, they're
super similar.
And for doing the texturing, the stuff that I do, you can only do that in SolidWorks. So
that's a mesh-based tool, which SolidWorks
that's a mesh-based tool that's proprietary to SolidWorks. So I'm a big fan of Solid Edge, but realistically, if you're only going to have one program installed on your computer and you want to do stuff like this with the texturing, you're better off with SolidWorks. I think there's major advantages to Solid Edge, but I'm in the minority there.
Okay, yeah. So I mean, what he's saying is have both. But Solid Edge is currently actually free for you to legally download and use for personal use, which is quite awesome, actually.
Yeah, that is a big advantage, and it's not a slouch of a program. I do all my CAD in SolidWorks, and then I just put I do all my CAD in Solid Edge, and then I just put the textures on in SolidWorks. So.
Yep, and then Ventilate Accelerate says lots of utility work. Engineering is still done with AutoCAD, right-of-way sketches for comms, power, etc. So this is what we were talking about earlier. AutoCAD, 2D sketches of a lot of layout stuff like that.
It's used a ton in a ton of professional.
That actually makes perfect sense. That makes perfect sense. I totally see that. I've done some layout stuff with SolidWorks sketches actually, and it's just not.
Yeah, it's not there. I mean, AutoCAD is optimized for 2D drafting, and it's the best at it.
Yeah. Let's see. Does the chairman?
Yeah, there's plenty of Lock 17 stuff that I have out there. I'm killing the 17 on V3 though. I'm not gonna. I'm revising V3, and the 17 slide is going to be a part of that.
And then we have an important question here, which is from Be Free or Die Trying. Hydrogen isn't hard to make. Just got to work out how you want to compress it. So if you're making hydrogen on site, there is no real motivation to compress it. You don't need to. So hydrogen is actually pretty difficult to make on site. It's expensive to do. There's a couple ways to do it. The only legitimate way nowadays is to use a electrolysis setup, and that is not as easy as people would think. To get pure hydrogen in the quantities needed for lighter than air aircraft.
That's really interesting. I would have thought that it was. Isn't it just like a wire and some water? I didn't think
it is, and I've done that. That's easy to do. The problem is you get amounts of hydrogen that are tiny. The amount of hydrogen you need for a balloon is orders of magnitude more than you'll generate with your little homemade device in a year. That's kind of the order of magnitude there. Also, making the hydrogen pure without any oxygen contamination is also more difficult. It requires careful design.
So easy to do, shitty, very difficult to do, as well as you need to.
Exactly. Basically, yeah. I mean, you can get commercial equipment. It's all six figures. So that's I think that is the best option to fill balloons. Relatively low cost, and if you can get decent priced electricity. But yeah, it's actually not super simple. Let's see. We have
what material?
What material? Classic question. And
PLA plus.
Yeah, it's gonna be PLA plus or carbon fiber nylon. Currently, those are the two best options.
PLA plus is an amazing material.
It really is.
You give up a little in like long term, like, you know, if you're subjecting it to like very high heat over a long period of time, like,
well, yeah, it's heat. I mean, heat is even sunshine. I had an Orca lower fail due to sunlight actually once.
But I
It
mean,
softens, but yeah, structurally it's incredible stuff. It prints awesome, incredible layer adhesion, great impact resistance for long term stuff. Some carbon fiber filled nylons. There's a few options.
Yep.
Some are better than others, but I mean, nowadays there's a lot of good options, I think. So, I mean, that's basically what it's boiled down to for me. Those two options.
Yep.
So,
And that I completely agree. Those are the only two materials I print guns in.
Yep, it's the same here. I mean, there is some interesting filaments, but they're esoteric and they're not there right now. They're not there yet. Okay, over to YouTube. We have a few last questions on YouTube. So that's everything for Odyssey. Let's see. Yeah, so Simon, oh, my device has gone to sleep. There we go. Simon Claret says organic shapes are easier on your printer, and that's true. I mean, just not having a sharp curve just means your head has to slow down and then speed up again. Why would you make your printer do that?
Also, a flat surface shows imperfections more. I mean, you know, my frames look so good printed because there's very few flat surfaces. You know, it's either texture or a bunch of very organic curves. Like,
it's hard to spot problems. Yeah.
It hides problems a lot better.
Yeah. Though your prints should look good anyway. But
you know.
But yeah, no, absolutely. If there's no, when you're 3D printing, making things with sharp corners like traditional guns have, that's because they're machining them. If you're 3D printing it, you have a whole different set of design requirements. And I've talked about this in other streams, you know, designing for manufacture, designing your part to be optimized for 3D printing rather than using more traditional techniques like you'd find with machining. So
what would you call that, Tim?
Like a fancy term?
Yeah, like some fancy dick suck term.
I wanted to avoid that word if possible.
I
don't know.
Affordances.
I have to think crossing a river, but not crossing a river. Not crossing a river. Affordances. That's I'll have to remember that.
We're avoiding fording.
Exactly. Okay, so let's see. AutoCAD is a huge step up from drafting by hand.
Yeah, that's true.
But I'm not 3D modeling in it.
Also true.
Okay, so let's see. There's a few of these. We've got to knock through these. 360. So Fusion 360, I assume, noob here. Solid Edge installed during the stream. Awesome. Way to go. Time to learn something new. I have a firearm built from each of your designs and really respect you both. Thanks for the knowledge, you guys. Awesome. That's Michael. That's awesome. I hope you are an example to the rest of the viewers to get yourself some Solid Edge and step up your game.
Who knows what you'll be. Michael, if you're on Twitter and you have a tech question, just at me and I'll do my best to give you a hand.
Awesome. Yes. Let's see. Simon Claret said it's been done with radio. He's referring to making hydrogen. You shake water apart. That method. There's a lot of. There's some other methods actually as well using electricity, using heat. Basically, I mean, obviously there's the iron contact method from way back when. There's a lot of different ways of doing it, but none of them are easy to do at the scale needed at home. It looks easy on paper, but to actually practically do it's still very expensive. We will be doing it here at some point, but it's not something to be taken lightly. Like Hippocarius says, hydrochloric acid plus zinc. And yeah, there's actually the method that's been accepted historically was to use sulfuric acid and iron to produce hydrogen. The problem is it's actually stupid expensive. Like you need a huge amount of acid and iron to produce gas. I mean, you can balance the equations out yourself if you don't believe me, but yeah, it's very, very expensive getting that much. It's ridiculously expensive to get that much ingredient. So yeah, that's not really a good option. Let's see. Yeah, this is also a problem potentially.
Question for me: would you consider making a version with all the surfaces? Nope.
For metal plating. You don't really have room. I mean, metal plating is so thin anyway. I don't think it would be a problem.
Yeah, just metal plated as it is. If I inset anything, you'd have holes.
I just played it as is. Shockburn says, can I design a lower with U-bolt front lugs? Actually, the front lugs are really interesting. My problem is using front lugs that I can use with standard takedown pins with a proper detent, which I really, really like. So probably not. I'll probably be continuing. The new lower is going to have a different style of front takedown pin plate, kind of more integrated in a nylon, and it should be not the only reason we've had failures. I don't know if you've had a failure, but I've seen some failures with plates, and it's mostly due to them being made from polycarbonate, which is what I make my front plates from for various reasons, preventing creep and such because of their current design. And polycarbonate has fracture issues under certain use cases. So I'm going to keep using printed plates probably moving forward for the foreseeable future, with an option for easier to make metal plates. So we might have an option for metal plates as well if my new design works out. I'm going to have like a different capture nut design, so we can just use a simple two-dimensional plate with no complex features, which should make it very easily laser cuttable. We'll see.
Send, cut, send. I love it.
Exactly. Yeah. Let's see. Nick says, has resin printing gotten to the point where it's viable?
Nope.
As far as I've seen, no. Even the new resin's out. It has very, very serious. It has very serious, basically cross-linking. It doesn't. It's very brittle. Even the high-tech resins.
It is weird because if you described both of these technologies to me like I was a fucking alien, like if you described FDM printing and resin printing, I'd be like, well, obviously resin is stronger. And it's just one of those things that it's never reached the like potential that it sounds like it should be at. Yes, and he's gonna say no.
Yeah, no. Also, is Cura Ultimate a good slicer? The answer is no. And Cura Learn a Different Slicer? The answer is yes.
It's
so you should. Cura is just backwards the way it's designed. It's backwards, and they have a poor. The SDL viewer is poor quality. Chairman disagrees. I know.
No, you're right on that front, but the output is actually pretty good, and it's pretty easy.
It's no better than other slicers.
Yeah, but it's easy to use, and it has profiles for everything.
It has backwards, like not well tuned profiles. I don't know. I would check out Prusa Slicer. They have done a legitimately really, really solid job. That's what I use.
There's literally nothing wrong with Prusa Slicer. It's good. But
excellent.
Cura is also good.
I don't know. I have Cura installed. I've used it a couple of times, and I've just always just gone back to Prusa Slicer because it's got a weird workflow.
It's because you're a fanboy. I find the Prusa Slicer workflow incredibly weird. I really don't like it.
You get everything set up, you load your model in, and then you slice it. Boom, done. And then you can flop back and forth between the slice view and the mesh view. It's like, what could be simpler?
Yeah, I drag my model in, I set it up, I slice it.
You're stuck in this little, all your settings are in this little tiny box. You can't even make it big. Like you got to scroll and scan through the little menus to find settings. It's like,
okay, well, hold on.
It's like search. You got to like search in the newest
Actually, let me revise that. Okay. Cura 5 fucking sucks because they did two things that I hate. You can't expand the menu anymore.
Oh my gosh, that's even worse.
Well, no, like you can't drag it to make it bigger.
Yeah, I know. I'm saying that's even worse. You could before, but like even then, like you're gonna drag it every time, make it a little bit bigger. It's still this little box.
It remembers its settings when you open it. But here's the big.
Okay, fine.
Here's the biggest sin that Ultimaker 5, fucking Cura 5 committed, and it's unforgivable. They put on smooth scrolling, and you can't turn it off. So when you're using your scroll wheel in the menu for the settings, it tries to like smooth out your scrolling. So you're not like your scrolling is like disconnected from what you're actually doing on the scroll wheel. It feels like it's rubber bandy, and
you've heard it from the man himself.
Oh no, I absolutely hate it, but it still does a good job slicing. But
okay, I just their interface is so bad.
I hardly ever use it anymore because
bamboo slicer.
Well, my only printers now are Cheaties and my bamboos, so I either just use Cheaties slicer, which is just a pretty good version of Cura that has the LAN stuff for their printers baked in, or I use bamboo slicer, which is pretty good. It has some problems, has some glitches, not all the way there, but it's okay.
Yeah. Yes, I don't know. Okay, so we'll agree to disagree on that one. So Milo says, I know how to model a bit, but I'm worried about doing that when these programs are online and uploaded to the cloud. Fusion 360 at least. Is there an easy way to circumvent this issue?
Solid Edge.
Yeah. So Solid Edge, does it probably reaches out to their licensing server, does it not?
Yeah, it pings a licensing server on start, but it doesn't.
But like, if you, it doesn't send. And if you disconnect your internet connection, I'm sure it still opens. That's the way Solid works.
Well,
I don't know how that would work because I have a SolidWorks license, but it connects to their server. But if I turn the internet off, it won't lock me out.
I don't know. So Solid Edge licenses actually a bunch of different ways. So you can do a local license, which is something that I do from time to time. You can also do a licensed server that you own and run. So that's what we do at work. We set up a licensed server, and any computer that wants to open Solid Edge reaches out to that licensed server that we own and run and opens that license file. Or you can do, a cloud thing where you reach out to like Siemens to, authorize when you open up. So they give you flexibility, and I actually just don't know how the free edition
free one works.
Does its licensing. I'd assume that it either reaches out to a Siemens server, or they just give you a local license. Either way, it's not always online, and
it's not like Fusion 360's online setup.
Yeah, that's just like an opening to license stuff. So like, if you were really worried about that, you can block. Yeah.
I don't think it's a big concern with the software running on your computer. There's ways to deal with that.
Yeah, it's this is industrial software. The IP considerations alone for sending telemetry about your actual models back home
are pretty serious.
Yeah. And we know it doesn't do that, at least for like the actual commercial versions we use. We're pretty tight about
that. So I don't think it's going to be Fusion 360. Yeah, I don't like cloud-based programs at all.
It's not a cloud-based program.
Yeah, so I don't know. It seems pretty legit to me just looking at it. And I've downloaded it. I haven't played around with it. So let's say we have one more question here, I think, which is from Simon Claret again. And he says, are either of you printing the RDB9? I think he's referring to the belt-fed 9mm.
No, but I'm interested.
Have you seen that?
No. When did it drop?
It was the guy on Weapons Guild that's been developing for a couple of years, and he just put it on Odyssey recently. Like he came out of nowhere. Have you heard of that?
I have. I haven't really seen much of it though.
Yeah, it's roller delayed. He has. I downloaded. He's got super cool, like really great photographs in his documentation. It's a very involved build though. I'm not working on it right now. I have looked at it though, and I have all the files and I have it for reference and stuff. So it is quite interesting.
I've been meaning to do a build with AGCast, so maybe that'll be one we do together. Because
I know he said he wants to do it.
Yeah. I remember him talking about that. So if he's building one, I think I'll build one with him.
Yeah, and I think this is a good place to drop off. 3D Arms says weirdly you can resin print dentures. Yeah, I know it's weird. I'm not even sure that works.
I feel like you could not, FDM print dentures. They just wouldn't be very, comfortable.
But they resin print them all, and I'm not even sure. Like, I don't want resin in my mouth. That seems weird. But I guess they have like.
Yeah, they resin print boxing gloves, bicycle helmets.
Yeah.
I'm waiting for someone to pirate Carbon's design engine. Check it out. It's pretty cool. Look up Carbon design engine. They have a whole thing for basically doing tuned elasticity with 3D printing in resin, or actually 3D printing in any elastic material, really.
Yeah. I see that. That's cool.
Yeah, it's super cool.
tedious route work.
But the software costs a fucking shit ton of money, and it, to my knowledge, it hasn't been cracked yet. So fingers crossed they crack it.
Because working with rubbery materials with resin, I don't know. There's different resin printing technologies out there. The resins that you can use with your basic,
it's not defined. It's not like
I know that. I'm just saying,
but
Yeah, I know that. I know that. But I mean, but you have to have the right resin to make it, to actually print real parts with it. But yeah, it is like resin printing does have some really, really cool things you can do.
Well, stuff like this would be really cool. Like the carbon design engine. I'm waiting for that to come out because that would be awesome for gear.
I'm looking at that right now. Yeah.
It's pretty insane. You should check it out. But hey,
Yeah,
I gotta drop off.
Same here. I was gonna drop off like 10 minutes ago, but I think that's the last comment. So I think we're all through. I mean, we have some more, but nothing super major. Just this one.
After.
Okay, so I'm gonna.
You missed his next comment.
Okay, so all right. So with that, I think we'll just, if you want to sign off, Chairman. And
yeah. God, what was I about to say? Hey, how many people watched this through to the end?
I don't know if you watch this from like beginning to end.
No. I mean, how many people do we still have?
Oh. Well, that doesn't mean they watched it. We have 40 watching right on YouTube.
That's
and
insane.
37 over on Odyssey.
I was expecting after 3 hours of talking about the most nerdy shit, we'd have 10 people watching. So hey, everyone, thank you so much for watching. And
absolutely,
if you've decided to check out Solid Edge due to my glowing recommendation, please fucking ping me on Twitter. If you have a Solid Edge question, I'll do my best to answer, or at the very least, point you in the right direction to find your answer. Because it's not a big community, so I want to help.
Yeah, it's and definitely. I mean, it looks like it's pretty cool. You can get like fully serviced professional CAD software for free, which you can do all kinds of stuff with, for personal use, of course. So that's super awesome. Definitely check that out. Thank you everyone for watching. Everyone who's been here. Yes, Odyssey for the win. Everyone who's out on Odyssey watching, thank you guys for being on Odyssey. Who knows how long I'll be here on YouTube. I didn't think I'd be here a couple months ago. So we are still here on YouTube. We're also on Odyssey. So everybody on YouTube, be sure to head out to Odyssey, subscribe to me out there, odyssey.com, and follow me out there for the next stream as well.
And drink a glass of raw milk for Tim.
Absolutely, guys. All right. So thank you very much. And I will catch you again sometime later, hopefully next week. All right. Good night.